Okay, so I think now we can start. So Ulrich and and myself, Cedric. So we are the two co-chair present on site for the doctoral consortium. There is also Antonio Uva, we probably will join remotely later on, and Chek Tien Tan, which is also joining this afternoon, I think. So maybe just a quick opening session, especially because we are a bit late. So just to remind you what is the goal of the doctoral consortium. So the doctoral consortium is a very good opportunity for PhD students to present and receive feedback about the research and also direction. And it's also a very interesting chance to get some guidance from mentors selected from experienced people in the field. And we also hope that it will help to build lasting connection between students and the mentor that can continue even after this doctoral consortium. So the general format for today is we'll have first some short talk in the morning and in the afternoon session. So we will have 6 in the morning and 6 in the afternoon session. The short talk will last around about 10 minutes, and we will have around 5 minutes for questions just after that. And then after each short talk session, we'll have some mentor guidance and discussion. So it will be 1 hour mentoring session. So yeah, where each student will meet up in person with his mentor and will have time to talk. And of course, we'll also have some breaks and the lunch. And so it will be also the occasion to continue the discussion between with mentor and also with some chairs and even between students. Maybe a quick look at the statistics about the doctoral consortium. So we had 13 submissions. We select 12 papers among these 13 submissions. So we just discard one. It's not, at the beginning, we didn't want to discard only one, but this submission was really not suitable with the DC, so we discard it. And so each paper received 2 reviews. And finally, we discuss the decision among the 4 chairs. So a quick look about the students. So I will not name everyone, but the idea is we get 12 students selected. We have a bunch of them coming from Europe. I think 3 from Italy, 2 from Germany, 1 from Belgium, another from Ireland. And so basically, I think, yeah, 8 from Europe, 1 from the US, 1 from Singapore, and 2 from Australia. So that we are 4 chairs for this doctoral consortium. I already named all of us, so I will not start again. And we also have a bunch of mentors, so 12 mentors, 1 for each paper. I will not also name all mentors one by one, but we have the list here with the picture, so you can probably recognize your mentor. Yeah. So yeah, I think we really want to thank also all the mentors that have accepted to be part in this doctoral consortium. I think it's very important to mentor new students in the field. I think I will let Ulrich present the program for this morning session.
Yeah, good morning. We can already ask the first speaker, Jamie Gower, to set up the laptop. And yeah, I won't go into the detail. I will just announce every speaker when the speaker is there. So welcome the first speaker, Jamie Gower. With the submission was titled "Utilizing Augmented Reality for Performance and Decision Making in Collaborative Time-Critical Environments." And the stage is yours.
Hello, as just mentioned, my name is Jamie Gower, and the work that I'm doing for my PhD is focused on utilizing augmented reality for performance and decision-making in collaborative time-critical tasks. The goal of my research is to address the research gap of AR support for time-critical tasks and to evaluate the use of AR for supporting performance and decision-making in collaborative time-critical tasks. For the purpose of my research, it's been split into 3 user studies. The first looks at whether AR improves performance and decision-making in collaborative time-critical tasks. The second user study looks at what visualizations and annotations can help to improve performance, decision-making, and collaboration in time-critical tasks. And the third user study looks at how to further optimize AR for performance, decision-making, and collaboration in time-critical tasks. For the purpose of the first user study and the following ones, a task was derived that had contained key elements of military tasking. So 2 participants were required to collaborate on a hostile elimination task. Participants were given the role of either a commander or an operator to replicate a command control environment. So the commander would act as the advisor to the operator who would carry out the commands. The objectives were hostile elimination and avoiding loss of life, and the additional objectives to include more decision-making elements were disposal of explosives, rescuing of allied forces, and defending an allied base. For the conditions for the first user study, they were no AR and AR. As you can see the image there, the no AR condition had all the information supplied by the UI. In this case, we used StarCraft for the platform for this task. The AR condition used the HoloLens to extend the display to contain all the to supplement the display with the AR information, and a comparison between the two was done. The key elements for creating the task for these studies were to make sure that it was high stakes in nature, allowed little time to consider information, involved information certainty, required a need for action, and involved rapid decision making, as these are general elements that are included in these time-critical tasks. The hypotheses for the first study were that AR would enhance the ability to perform the primary task, AR would decrease completion time, errors, and cognitive load, and AR would enhance situational awareness, decision-making, and collaboration. The independent variables were condition and map, and the dependent were hostiles eliminated, completion time, errors, cognitive load, situational awareness, decision-making, and collaboration. The measures used were hostiles eliminated, response time, errors was counted as casualties that occurred. The RAWNAS TLX was used to assess workload, and the situational awareness rating technique was used to assess situational awareness. The Melbourne decision-making questionnaire was used to assess decision-making, and a collaborative questionnaire was administered to assess collaboration. The results found that AR led to significantly more hostiles eliminated. However, all other findings were non-significant. Currently, I'm up to study 2, which looks at what AR visualizations and annotations improve performance and decision-making and collaboration in time-critical tasks. The hypotheses for this study are differences in completion time, errors, cognitive load, shared decision-making, and collaboration will exist between conditions. Based on the feedback and the analysis of the first user study, there's been several task alterations to make the task more collaborative in nature and increase time-critical elements. These include increasing the amount of collaborative actions required, decreasing the total task time, and decreasing the timers of the additional objectives, as well as increasing the amount of information sharing that is required within the task. Further to this, the task still contained the hostile elimination task, which required participants to eliminate hostiles within a set amount of time. However, in this case, participants were required to collaborate, as one participant would act as the main forces, and the other participant would act as the support forces to replenish ammunition to the main forces in order to effectively eliminate hostiles. The roles of commander and operator were dropped for the purpose of study 2, as it didn't feel as collaborative in nature as was assumed. So the explosive disposal task required participants to dispose of an explosive that was that would frequently occur in the scenario. For this task, participants needed to collect up to 4 relics. Each participant could only see 2, so they were required to share information, or are required to share information of where the relics are in order to obtain them. A viewpoint of the relics, a little diagram of the relics can be seen there. Player 1 can only view 2 of them, and player 2 can only view 2 of them as well. And the image at the top is an example of how the main and support forces work in regards to their ammunition and restocking ammunition. The Defend Allied base requires participants to acknowledge a base that was attacked in a relatively short amount of time. Both participants are required to acknowledge this via a keyboard input to complete the task successfully. The purpose of this task was to add extra time-critical elements and pressure into the environment on top of all the other objectives that were going on in the main task. The rescue stranded squads required participants to send at least one unit, both send at least one unit to a stranded group of units to bolster their forces. Once saved, they would bolster their forces. They had a limited amount of time to do this task as well. For the design, this is currently under review, but the current design is that participants would undergo training until they're deemed fit to do the main task, and then undergo 10-minute runs of 6 different conditions. So the first condition being the baseline, which is no AR. Second condition being sticky notes, which allows the users to annotate the augmented map that is extended from the display with sticky notes. The highlight, which allows participants to highlight key areas. Lines, which I have a larger image a bit later, and indicates where the position of units located on the augmented map relative to the game world. And then a combination to the last 2 conditions are a combination of highlight and lines and sticky note and lines. After completing these conditions, participants will undergo answer post-condition questionnaires, which are the raw NASA TLX and the Alberta Shared Decision-Making Questionnaire. The independent variables for this are the conditions, so no AR, sticky note, highlight, lines, sticky note and lines, highlight and lines. And the dependent variables are the completion time, response time, errors, collaboration, shared decision-making, and cognitive load. Once user study 2 has been looked at and completed, and an analysis has been conducted, the expected next steps are to look at to look into further optimizing AR for improving performance, decision-making, collaboration, and time-critical tasks. This is a slightly bigger image of the lines that is hopefully a bit easier to see than the previous one. And thank you for your time.
Thank you very much for your presentation. One thing I'm pretty amazed about is that you make the assumption that AR will decrease the cognitive load. And the few studies that we have on that are pretty mixed.
Yeah.
And it's really based on, notably among the ecological condition. So could you discuss whether you think your condition will be somehow ecological or not, compared to the real task, which we're not going to assess in real life, I guess?
Yes, for obvious reasons, I'm not going to assess the task in real life. So the question was whether it would reduce cognitive load. So at the moment, for the first study, obviously I believe that it would decrease cognitive load. For the second study, slightly less. Obviously, I haven't determined a direction in which that will result. The main reason that I was assuming that it would decrease cognitive load is because it is very strategy games are very involved. So, and obviously I'm using StarCraft. Probably should have mentioned that for the purpose of this. So I was hoping that having the ability to view the whole entire map, which you can see here, from a top-down perspective with relative ease would make it a bit easier and reduce the cognitive load. Same with having the information displayed around the screen, because your screen would be less cluttered with information within the user interface that's usually not modifiable. So I don't know if that answers your question. Sorry.
We have another one, Steve.
Thank you. So I think this is really important stuff to do. And I'm trying to understand, however, because the talk went by so fast, I didn't get a chance to read it in advance, exactly what the augmented reality condition is doing. So it looks like in one of them, you've got a separate display presented with a HoloLens next to the flat panel display, which it seems to me could have been done using a looking glass or other kind of autostereoscopic display if you wanted 3D, or even a separate monitor if you wanted 3D or didn't really need 3D. So there's one question. And the other is the one that's down over here, is that done with a HoloLens, in which case we're not really seeing through the display? Or what were you using in the second study?
Okay, so for the first one, which I assume is where the first question comes from,
Yes.
this one.
Right.
So the idea with the first study was kind of to supplement the displays using augmented reality, because in real world environments, obviously you wouldn't be able to extend certain military displays because they don't like people interfering with the display. So the idea was to supply additional information using AR without interfering with the underlying systems, which is why we use the HoloLens to extend it rather than using an additional monitor.
There's also a privacy issue, which of course the HoloLens is going to appeal to, right?
Yeah.
Okay. What about the second one? Because your graphics are obscuring the table, which would indicate it's being shot through the camera as opposed to actually being seen through the lens if it is being done with a HoloLens.
Okay, so this is with the HoloLens. So the hang on, can you rephrase that question?
Okay,
sorry.
That looks like it's opaque. It's blocking the base of the monitor. You can't do that with a HoloLens.
Yeah, okay. It's more comes. Okay, it's very hard to tell. The lighting of this picture isn't the greatest. Sorry.
Okay.
It isn't actually blocking the table. The table is there's a faint line here. It's just the lighting and the angle that the picture was taken on doesn't do it.
This was probably not shot with a camera through the actual lens of the HoloLens. This is using the integral camera that's part of the HoloLens.
Yes. Sorry.
And it looks like maybe you might have made the graphics be slightly transparent.
Yeah.
But that's not what's going to happen on a real HoloLens unless it's an incredibly dark room.
Yeah.
And this is clearly not.
Yeah. So the I'll have to get back to you on that one.
Okay.
Yeah.
It's a hardware problem, right?
Yeah.
You're not making the hardware, and there are already things that will obscure the light partially in the display, like a Magic Leap 2, for example.
Yeah.
Or video see-through.
Yeah.
But that really could affect the results of a condition in which you're trying to look at the map, and instead you're seeing the map plus also the crap that's spread across the table.
Yeah. That's a good thing to consider. Yes.
Okay. Thank you.
Thanks, Steve. Do we have another quick question? Not, then let's thank the speaker. And we're switching to our first online speaker. Can we check that the online speaker can actually present? Dikshan Chui.
Yeah, it's T-shirt Cui.
Are we not seeing your screen on the projector yet?
I'm currently sharing right now. I am hearing echo from live, I think.
Yeah, we'll switch off the microphones once you're set. Okay, we do see your screen now. Are you ready to go?
Yeah, I'm all set.
Okay, then let's welcome our second speaker, Dikshan Cui, with the title The Effect of Out-of-Body Experience and Tactile Feedback on the Sense of Embodiment in Virtual Reality. The stage is yours.
All right, thank you so much. Hello, everybody. My name is Tishuan. I am from Purdue University in the United States. Currently, I am a third-year PhD candidate. My research area is within the virtual reality, and my research focus is on the sense of embodiment. So for my PhD dissertation, I want to work on something related to out-of-body experience. To get started on that, I want to bring out a brief introduction regarding some of the important concepts about the study. Then I want to introduce some of the research questions, the methodology that we have come up, and also the current progress regarding the project. So to get started, the sense of embodiment is a phenomenon that we feel our own body by receiving a flow of information related to vision, touch, proprioception, and also neural system. This can be done in the virtual reality by providing a virtual avatar to the users. And there are also a lot of different dimensions that can be used to define the sense of embodiment, such as body ownership, sensation to tactile feedback, and also external appearance realism. So from this phenomenon, there is another phenomenon called out-of-body experience, where the users, they will perceive themselves outside of the virtual body. So they can achieve this by having either a different or a dislocated body. So you can have a virtual body that's out of position in relation with your realistic body, or you can have a distorted body while still embodied into that virtual avatar. So more focus onto the out-of-body experience. It is generated by asynchronous perception, and it can be done by 3 different sources. It can be done through vestibular central representations of one's image and somatosensory and also proprioceptive inputs. And it can be providing different sensations to different participants. So it was confirmed in the previous studies that OBE can happen in both healthy and non-healthy populations. On the right, we have a previous study that was done by Veranda et al. They have been conducting a out-of-body experience, and their results asserted that OBE reduces the fear of death. And in other studies, it was found that after exposing in VR with out-of-body experience, there is a significant increase in acute dissociation, which is a disorder that makes people feel disconnected from the real world. So in general, if people are trying to achieve OBE, they can be done by perspective manipulation. So most of the VR applications uses first-person perspective nowadays, and by using third perspective, they can simply achieve OBE by doing that. Currently, the issue is there is a really lack of comparison in between first-person perspective and also third-person perspective. There were studies confirming that third-person perspective can achieve higher illusionary ownership. And also there is an advantage of using the third-person perspective that it generates a greater spatial awareness for the participants, especially in immersive environments. So that is one of the motivation of conducting this type of study. The second concept I want to briefly introduce is the tactile feedback. So this refers to the physical response to the user, and it has been found in 7 different studies that it generates a significant effect on the sense of embodiment. And now, due to the emerging technology, it is possible to apply tactile feedback on different body parts. So there are several sample images on the right. This is currently applicable to upper body parts such as the arm, the hand, and also the fingertips. There are also haptic vests that can provide tactile feedback onto the upper body. And there's also tactile feedback devices that can be provided to the lower body, such as the legs, knees, and also the foot. So with all the related work done in research, we have designed a 2x2 study, which having the perspective as the conditions and also the tactile feedback as the other condition. We have first person versus the third person, and also with and without the tactile feedback as a second condition. The research questions focusing on which are the embodiment dimensions that could be impacted by OBE, tactile feedback, and we're also interested in seeing in exploring an interaction effect in between OBE and also tactile feedback. So as for the methodology part, here I have set up this virtual environment application. So on the left, this is the showing of the virtual environment in the game engine. And on the right, we have designed, actually we have found 2 different virtual characters for both female and also male. So in the actual application, there is going to be a mirror in front. This is generally designed in OBE studies, so the participants can able to perceive themselves within the mirror for their virtual characters. On the left, we have, this is a first-person view, and on the right, this is a third-person view. So the study process is really similar to the rubber hand illusion study. There is this brush on their major hand. Participants are going to be sensing the tactile feedback provided by the stroke of the brush onto the hand. And then after a minute, they will exit out the application, take off the headset, and be answering on our embodiment questionnaire. So we'll be conducting our data collection analysis through embodiment questionnaire that was done by Gonzalez Franklin and Peck. We're using a 7-point Likert scale, and we're importing this questionnaire onto our online Qualtrics survey system. And we'll be analyzing the data using IBM SPSS, and we'll be running a ANOVA testing. So the current phase of the study is we're still finding participants and collecting data. Currently, we have several participants that have been conducting the study. We also run a pre-test to test out if the VR application actually works. Some of the future ideas for refining this type of research is that, first of all, we want full body trackers for rich animation. Currently, the tracking is only done by the HMDs and also the hand controllers themselves. So there is a limitation on how much animation that can be achieved using this application. And furthermore, we want more complicated interaction in between the virtual characters and also the virtual objects. So participants can actively seek for interactive tasks. And in that case, it will provide a better agency and motor control. And last but not least, we want to consider different instruments of visual manipulation. So instead of conducting perspective changes, we would like to import something like a distorted body for different OBE generation methods. And we believe by having that, we can have a better understanding on how OBE affects the sense of embodiment. So that is the end of the presentation right there. Thank you guys so much for listening. I'm now open up to questions and comments.
Thanks to the speaker. Do we have any questions? Yeah, we have one question from Sasha.
Thank you. Hi, thank you very much for the presentation. It was really interesting. I actually have a few questions with regards to the avatars that you use. I've read some of your previous research, which was with regards to tactile hugging. And I know you're kind of trying to aim for more realistic avatars. Are you actually planning to cater, basically make avatars which are more diverse or maybe resemble the actual participant more, or perhaps maybe even go for less realistic avatars, or maybe not even human ones? So that's my question.
So, okay, sorry. So the question, are you asking regarding why we choose this type of avatar?
It's more
Or
regarding
is it-
your future plans, or if you think maybe like changing avatars will actually give you different results.
Yeah, I think that's a really good question. So, in my previous studies, although this is actually the second study I've been using full body avatars. In the previous ones, I have been conducting studies with just the virtual hands themselves. We do found significant differences in the virtual appearance or the external appearance of the virtual avatars. It turns out that realistic avatars can generate a better sense of embodiment in some dimensions, while the mannequin avatars are able to generate a sense of embodiment in other embodiment dimensions. So I think, if I recall this right, realistic avatars provides better external appearance realism and also a better agency and motor control, while I think mannequin was able to provide better body ownership. And there was also studies regarding avatars saying that there's uncanny valley effect. So if an avatar gets really realistic, the sense of embodiment or also the perception of the realism of the avatar will actually go down, because it causes a style clash with the virtual environment itself. So I believe if we're conducting future studies such as using distorted bodies, we might be able to compare different body models and also avatar styles as well. I hope that answers your question.
Yes, it does. Thank you.
Thank you so much.
Thanks. Do we have another question? Yeah, from Michele.
Yeah, thank you. Very interesting research. Actually, we are assisting in a lot of body vibration systems, which took torso or back, shoulders, and whatever. So my question is, if you notice a significant difference between different application points of the tactile vibration. And if you eventually will consider also these suites that come from game industry, which are pretty exploding right now. Thanks.
Yes, that's thank you so much for the question. I think it's really interesting. I actually have done a previous study last year for ISMAR as well. There was this haptic fighting game research that I've conducted, which uses the B haptic vest that provides tactile feedback on the upper body. And I was also considering maybe in the future using upper body tactile feedback or even just full body tactile feedback using OBEs as conditions. That is definitely one of my research interests. Sorry, does that answer the question?
Yes, thanks.
Mm-hmm.
So we still have time for one more question. Nobody? Then we'll be waiting for the speaker to finalize the setup. So our next speaker will be on site again, and her name is Megani Rajendran, and the title of her talk will be Towards an HOI Application for Digital Home Assistance.
When I was looking at the field of computer vision in everyday life, I started looking at activities of daily living datasets, ADL for short. And from my research, I found that as great as real life datasets are, they come with many terms and conditions. And it seems like an excessive amount of work. It's labor intensive, especially if you want to create datasets that researchers would find useful. So to create a large enough data set that account for the many ADL activities that occur within homes, researchers need to coordinate many resources, like recording people, getting their permissions, assuring them that no personal data is being collected, categorizing the data, annotating the data, ensuring that participants' identities aren't compromised, and, well, you get the idea. The gist of this is the real-world ADL datasets. They're time-consuming, laborious, and comes with reasonable privacy concerns. And then I started looking at models that were presented in the ADL field, and it seems like the real-world datasets cannot capture all real-life challenges that will be faced. Dangerous situations such as fires in the homes, stoves left unattended, and unexpected falling objects being placed precariously are examples of some of the dangerous cases that can't be captured in real-life video datasets without endangering the participants' safety. And that brought me to my research focus, where I realized that to create a system that is meaningful for the elderly, we need to train human-object interaction detection models, HOI for short, on realistic elderly-centric datasets. I'll be mentioning this a lot today, HOI, as that's the type of activity detection model that we want to use when we are looking at improving everyday living in elderly's homes. So from that, I have crafted the objective of my research to be to investigate how we can use HOI detection, so that's human-object interaction, algorithms with digital home assistants in elderly homes to enhance everyday living. And after discussions with my supervisors and colleagues, we broke the project up into two phases. The first phase is to focus on synthetic data generation that improves HOI. And the second is to understand the role of HOI in digital home assistants to create a smart system for enhanced home living. So in phase one, which is the phase that we are currently at, we're looking at synthetic data generation. And we made this one of our research agendas because, like I mentioned, we found that real data sets may not have captured many real world challenges that exist, and that actually impacts the efficacy of HOI models in everyday homes. So we're currently working to create a new data set with our novel synthetic data generation pipeline that allows for the comparatively faster generation of synthetic data that can contain more information than real-world data. And so to do this, we are engaging the use of post-tracking technologies and photorealistic RTX rendering devices that allow for the creation of synthetic data, and these tools are found within NVIDIA's Omniverse. An example of this technology in action is this Rio scene that we have created that I'm showing on screen right now. And this is using existing ADL datasets and the Maxine Post Tracker from NVIDIA's technology. And so I mentioned a couple of slides back that we want to create a smart system that leverages on HOI algorithms. And this is the proposed system architecture that we have come up with for phase 2 of our research. So the actual system components can only be derived when embarking on the design of this HOI-based digital home assistant with actual users. But an initial high-level concept is what's being shown on screen here. So allow me to just briefly go over how this system would work. So in real time, the video stream from cameras will first be pre-processed into a video feed processor before ADLs can be detected using the HOI-based ADL detector. And the detected ADLs allow the state machine to form an understanding of the activities that are happening around the elderly user, and thereby transitioning the system into the appropriate system state that responds to the activities that are happening in the video in question. In a separate stream, the IoT sensor data from other devices such as fire alarms, digital clocks, and thermostats, for example, may also be used in the state machine to form a more complete and robust picture of the situation around the elderly. And this system states will correspond to the different types of responses according to the situation that is deduced by the state machine. And as a result, the actions that will be taken by the system will be in the form of messages, digital speech, and or notifications. So this infrastructure will ideally be built upon existing digital home assistant frameworks. And this phase will primarily involve iterative developmental efforts with user tests and feedback that evaluate elderly experiences. Okay, so what is the significance of my research? For both phase 1 and phase 2, we are approaching it from an applied research standpoint. So from this perspective, we want to streamline real-world systems and equip them with analytical capabilities using HOI algorithms. So we're also working to streamline the process of synthetic data generation to enable improved HOI algorithm performances. So this project also seeks to contribute a knowledge database that informs people about the specific components in digital home assistants. For example, we are thinking of introducing a component that identifies elderly ADL, such as eating lunch, taking a nap, watching TV, or eating medicine, and then recording and helping the elderly to regulate these activities without having the elderly to manually key in what they have done. So you also recognize that the elderly have not done certain tasks like taking their medication on time or taking out the trash, and it will remind them of this. So through the development of a better design of such systems through the HOI-based approach, this project will add value to the society at large as we learn to cope with a largely aging elderly population. So this is a very brief overview of our research plan. Like I said, broken into 2 phases. So phase 1 includes the literature review of synthetic data generation methods, as well as the synthetic data generation for HOI. So that's where we are at right now. And then phase 2 would be to look at literature review for video-based digital home assistants. So we're hoping to do this by the end of next year, before we move on to develop the actual system that will be tested on actual participants. Yeah. Okay, so for future works, our future works include things like further research on synthetic data generation, as well as investigating how improved HOI can assist digital home assistants to enhance everyday living for the elderly. And there are also plans for us to release datasets and the relevant APIs that were generated in this project for the developers and researchers to further this work. Yeah, okay, so thank you. I have listed my email, so if you have any questions or any follow-up actions, you can just feel free to contact me. Thank you.
Oh, let's thank the speaker. Do we have any questions to Megani?
Are you using mostly egocentric video or just like external video, and how are you mixing the two together if you're using both?
Oh, I'm a current staff at NVIDIA, but I'm also doing my PhD at the same time. So I'm doing both.
Oh, sorry. Let me ask my
Sorry,
question. You mentioned a lot of things around video, and you're doing that for the object understanding and all that. Is that primarily from an AR like egocentric perspective, or are you looking at it from like from the outer view, and are using both? I'm just kind of curious about that.
Okay, so we are looking at AR for the systems approach, but for the synthetic data generation, we are not looking at AR at the moment, but we are thinking that, with the use of being able to detect activities within AR systems, like that would be very impactful for us. Yeah.
Okay, thanks. Do we have another question? Then let's thank the speaker again, and may I just ask Sharon to come up to the stage? Okay, then we'll head to the next speaker. So let's welcome Sharon Chesines. I don't know.
Don't worry, I'll introduce as well. Hello.
Let me just announce the title: Context-Aware Support for Dexterity Skills in Cross-Reality Environments. Yes. The stage is yours.
So, hello everyone. My name is Jeroen Seyses. It's a hard name with typical Belgian names. So, I work at Hasselt University in Belgium. I started my PhD at the end of 2021, which means I'm technically a first-year PhD student. But you will see, like in my slides as well, that my trajectory is not the most typical one. So a little bit about myself. I actually graduated my master's in computer science in 2019. But prior to my PhD, I was actually already working as a researcher in XR technology. The thing is that my whole goal and responsibility was to try and advise as many industries as possible on how XR can be used for them. So there's many different sectors that have never heard of the technology, did not know what it was, only heard like news articles about it. And they were very interested in it, but they had no idea how to actually get started on it. So my responsibility was to try and convince them how technology can help them by doing market analysis, by like sitting together with them, talking about what it can do, but also by building many different like demonstrators that were trying to be top of the line of the technology to try and showcase, hey, this is the potential for the future for your company. So you might want to invest in this kind of technology early on or become like an early adopter in terms of research as well. I want to showcase some of these demonstrators that I built because I'll also use them in regards to my PhD for fine-tuned dexterity skills. Now, the first one, or like one of the early ones that I built, is an AR cleaning demonstrator, where while cleaning a certain surface, you get additional guidance on, for example, where you've cleaned. If you clean at the correct speed, everywhere it's red, you'll be cleaning way too fast. You can see how dirty the mop that you're using becomes because they have certain procedures based on the size. But you can also just say like, hey, I've cleaned so much. Can I just see instead like what I still am lacking? So they can easily visualize for themselves what they need to do. There's also feedback built in, for example, warnings when you're like walking over a clean surface, of course, leaving dirt behind as well, or when you're cleaning in one direction and then you flip the mop around, which actually leaves dirt on the other side that you're actually spreading across. So we also tested this demonstrator. So we've discussed it with the biotech and they loved it in general. They also put me in that very nice suit over here. And we actually tested it as well in one of their cleaning labs, where we also added the Microsoft Scene Understanding for scanning the environment as well. So we could then say, okay, we have now this entire environment. How about we try and clean the same thing as well, which it allows support for. They also want to use it right now as well, but of course, that's something that's still in the pipeline. Another demonstrator that I want to mention, and it's going to be reoccurring a lot in my presentation, is one for XR welding. Now, for some of you who don't actually know, welding is the concept of like trying to like melt different metals together to create this very cohesive joint to make sure that things stay fit properly. We want to be able to see how like we can try and support these welders during the activity, because there's a lot of different things that can go wrong. It's something that was mentioned a lot by the industry and I want to try and focus on. So we started by building a simulation of the welding procedures where you can just use on any different object. We simulate the light that is reflected off of these objects and try to simulate the welding procedure as close as possible as well, where we can then see how can we provide guidance for these sorts of visualizations. And that's also what my PhD is focusing on, more of these guidance instructions. Now, just to quickly highlight, because I don't want to spend too much time on this, some other demonstrators I built as in regards to like assembly guidance for operators, where we use the HoloLens with hand tracking to kind of like detect which objects that they're grabbing, are they placing them in the right order, to try and give them some additional guidance. This was for the make industry, for example. Cleaning guidance was also with the HoloLens too. We also have a project that I was responsible for, where I wanted to build an environment for students of nuclear science, where they learned a lot about nuclear contamination. So we built a simulation model of the different nuclear radiations so that they can decide for themselves, oh, I'm going to try and decontaminate this room in this way, so they can test like if they know the procedures correctly. We also did the same for medical science, where we simulated this for like the fluids as well that's being used and combined together. What I want to mention is that the PhD focuses on these dexterity skills, because while I was a researcher, I noticed that this is where like the main bottlenecks are. Because first of all, they're highly desired by both individuals and the industry, because they're very hard to learn, often taking like years and years of practice. But there's a lot of like knowledge that you need to have while you're doing these things. And at the same time, you also have to like be very flexible, because for a lot of these things, you need to make changes during the motion itself. You're carrying out a certain motion and you immediately need to adapt to anything that's happening. In the case of welding, you see the seam behaves slightly different. It immediately means you're doing something wrong and you need to adjust as fast as possible. So this means that there's a lot of preemptive work that is taken in these sorts of like situations. So what I'm focusing on is to try and provide on-the-fly information during these activities to allow for immediate adjustments, both in the form of feedback and feed-forward. Now, feedback, for those who know the concept as well, this gives information on the current state of the operation, but feed-forward is actually that you try to visualize things while they're being happening. So someone is like trying to occur a change, the system will visualize how this change will like create other changes happening in the procedure as well. So it will tell you when you continue doing this movement you're currently doing, this is what's going to happen. This also brings us to our very first challenge in the PhD that I also want to emphasize for the doctoral consortium. Well, first of all, there's a lot of XR visualizations in the design space to explore. It's a broad field. And a lot of dexterity skills is done, but there's still a lot to explore as well. But we have a very particular problem with dexterity skills. That's that there's a very small gap in time between feedback and feed forward. Now, I like to illustrate this by using the Gulf of Execution from Norman. Basically, feedback is in between perceiving the state of the world and interpreting what you're actually seeing in that moment. While feed forward actually lies a lot later, where you already know what you're gonna do, you have your goal set and you're intending to act upon it. And that's when you're going to visualize things to make sure that these actions are supported as well. The problem with dexterity skills, this gulf is extremely, extremely fast. So there's such a small gap in between the time for feedback and the time for feed forward that they're technically merging together a little bit, because the moment you give feedback, they're already occurring the change. So the moment you give feed forward as well, it's already too late. We notice this with research that I'm currently doing as well. I'm doing some tests with welding, for example, and we notice it's very hard to measure, like, first of all, these changes in performance, how, like, where are they actually focusing, and what are other behaviors that are occurring as well. To give an emphasis, if we give them instruction, change your speed, they will change it in that moment, and then they will immediately be going too fast already, so they have to slow it down again. So the instructions are constantly overlapping with the intent of actually what needs to happen. My title also mentions context awareness, which might have not been mentioned so far, but I'd like to introduce the concept real quickly. It's the ability of a computer system to sense details of the external world and choose a course of action depending on its findings. A very nice definition from the Oxford Dictionary of Computing. For life procedures, like with dexterity skills, this can be many different things. For example, the tools that you're using, how the procedure is progressing right now, possible social settings of how many coworkers are around the user while they're carrying out. Are they gonna, like, behave strangely for someone like using AR in that moment? But also environmental properties, like how is the lighting gonna affect, like, all of these visualizations? How is, like, the current setting just in general, like affecting everything? And this is where tracking solutions and detection algorithms are, of course, of importance. But we need to, of course, highlight that there's a big difference between, like, having a proof of concept where we use, like, Ieruko markers, where you can just, like, test it out, and actually supporting the live procedures as well. That's why we think it's important to focus on what do we need to visualize in XR to support these live procedures, so that then people that do the detections will actually know what is, like, the most important thing to emphasize on. This brings us to, like, the second challenge, of course, is that the visualization should not be lagging behind user activity. Like I mentioned, this is a very fast procedure that's happening. So we need to have low latency tracking, but it also needs to be accurate, which typically doesn't go hand in hand together. And these tools should need to be at sub-millimeter accuracy. We have sometimes, for example, even with surgery, like to give another example other than welding, you have such a needle point accuracy, and deviating from these in any way at all will change the way that everything is going to be visualized and interpreted by the systems. We have the typical, like, detection algorithms, but of course they all have their pro and cons. For example, the markers are very easy to use, but very unreliable. We have other systems like the OptiTrack that's very accurate, but requires a full setup. And detection algorithms can be very compute intensive, but typically means you also need a server or anything like that, which can cause additional delay. See, I'm running a little bit over time, so I'm going to be really fast. There's also the challenge of realism versus performance, of course. As you could see with my weld, it wasn't the most realistic. We first had a technique of ray marching that we were trying to employ. The problem was it wasn't working on the headset because it was way too compute intensive as well. So we had to optimize it and to go for low-res marching cubes to be able to make sure that we can actually render it. Because if you try to go too high detailed, all the XR headsets are going to start lagging, and then people are going to get nauseous and they will not like it, which will also impact the studies a lot as well. These were the main challenges that I'm like focusing on. There's some final questions that I have listed for the doctoral consortium as well from these challenges that I was exploring. I would like to thank you for your attention as well. This is my contact in case you want to discuss further.
Thanks a lot for the presentation. Do we have any question to the speaker? Michele?
More than a question is thinking how we did in our laboratory similar applications in the past, and actually we get to the point that you already mentioned. How is the concept of the application is just a playground, but there are some challenges still in the technology. So basically, we also are carrying out a research which is pretty similar. We present tomorrow, so maybe you can give a look to us. And in particular, those dexterity skills, and how we are doing a very review in literature. There is a lot from VR where you have to move an object toward docking problems, but we didn't find much in this kind of forward feedback. So I think this is already by itself a very important so my suggestion is to focus just on this, because actually by solving this problem you can open a lot of application, both medical, engineering, and so much. So I think it's really a research problem worth to do it. So good work. So,
thank you very much.
Question, sorry.
So yeah, one more.
Hi, thanks for your presentation. So I had one question regarding the feedback part. So I'm imagining that the application of the system which you are trying to achieve would be something like, say, a welder is wearing a AR headset and he is receiving some feedback as he is welding. So then, like, what is the, like, could you give some example of feedbacks which you can see in the AR headset, which is like not visible while he's looking at, say, like the light which is coming and like the pin and itself?
Well, I want to like emphasize that with the slide that I actually have prepared as well, which is currently one of the works that I'm focusing on, which is also the periphery-based support. So one of the examples that you can do is like try and visualize things in the periphery. So really like in the corner of the eye, where like just the color or that general shape can try and provide information as well. So while you're looking at the weld, you can try and get this instant cue that can be used to like without losing like the focus of the user as well, make their adaptivity happen as well. But there's also like, of course, the whole concept of, but then you don't have like the mapped visualizations as well on the like object itself. This is one of the things that was actually like of large interest as well. See if we have like any focus retention happening from that. Hope that answers the question a little bit.
So we have another question from Steve.
Sure, this is fascinating. Obviously, the big issue over here is finding a task that this is going to work with.
Yes.
So have you taken a task like welding, which looks like you're concentrating on, and tried to get a sense of how low latency you really need to be able to weld well, or to be able to sort of virtually weld well, or even just draw well, for example? So if you actually try to analyze that for kind of a non-augmented task in which maybe you're looking through your XR3 or whatever headset you're using and trying to get a sense of whether you can do certain kinds of tasks with no augmentation, but just literally seeing the world, perhaps with varying amounts of introduced latency.
So I have indeed been like testing some stuff with that as well. I've also been excluding experts as well, like for example, expert welders. I've been interviewing them actively in like preparation for all of this as well, to see like what kind of like how much do they think that they see, because welding is also a dark activity as well. I've also been running some tests with the Vario XO3 and with also the Z Mini, for example, for pass-through AR. Of course, you have like a slight gap that is like not the same as realism, but in general, it seemed to be very accurate actually for carrying out these sorts of operations. The Z Mini was not as great, but the Vario seemed to actually have like great performance in terms of latency, and didn't really seem to be causing direct issues for like the fine-tuned movement. The biggest problem is, of course, like the tracking and such, because it can be very unreliable, can be slow as well. So that's actually like the first problem to tackle. But in terms of like actually carrying out the movement, it was actually very like doable.
And it's good you pick something which is just a 6-stop task of positioning and rotating. You're not worried about the individual fingers doing things.
Excuse me, can you repeat that?
You're worried only about a single rigid body that needs to move around, as opposed to real dexterity with lots of individual finger motions.
We are currently not looking at the finger motions directly. We were mostly looking at like the detection as a whole.
Which makes it easier.
Yeah, of course, it does make it easier as
Yeah.
well. So I could consider as well if there's like some stuff to like take into account. We do like use the actual welding torch that we have like hooked up to like try and like simulate as much, because it's also like that button that they have to use as well. But it could indeed be interesting to also look at the finger movement. This may be a good suggestion. Thank you.
And much harder. Thank you.
Thanks. Do we have another question? If not, then let's thank the speaker again.
Thank you very much.
We're moving to our second online presentation. The next speaker will be Sandhya Santosh, presenting the work Developing a Methodology for Co-Creation Using Extended Reality Technologies. Can we see if we have the next speaker on the screen?
Hello, can you hear me?
We can hear you, but we don't
Okay.
see your screen yet.
Okay.
So now we see your picture, your video. Are you sharing your screen?
I'm trying to. Okay. It should be. Okay. Oh no.
So far, we don't receive your shared screen.
Can you see it now? Maybe.
Okay, looks better. You should still see your settings menus.
Veranda. Okay. Can you see
Here.
it?
Yes, we can see your screen.
Okay.
Okay, then please go ahead.
Good morning, everyone. My name is Sandhya Santosh, and I'm a PhD student at the University of Bologna, Italy. And I'm currently on an Erasmus Plus mobility period at the Technological University of Delft in the Netherlands. My PhD research is focused on developing a methodology for co-creation using extended reality technologies. In this presentation, I'll walk you through firstly the concept of co-creation and the key elements to implement co-creation, getting into some of the existing co-creation platforms and why it's important, and my research proposal of XR as potential co-creative platform. I will also present my research progress demonstrating some XR applications I have developed, giving you an instance of my current work at TU Delft. Co-creation, a business topic nowadays, is emerging to various fields. In fact, researchers have anticipated the development of tools and methods that would extend the definition of co-creation to the domain it can be adapted and related to. Thus, in regards to a new product development, co-creation can be defined as collaborative development of a new value. The value being concepts, solutions, products, or services, etc., together with experts and stakeholders such as users, customers, suppliers, etc. In this context, I have laid out the three pillars or the key elements of co-creation as collaboration, interaction, and experience. How and where to collaborate, how to interact, and what will be the experience are the three main questions every user would have when the concept is introduced to them. Prahladan Ramaswamy illustrates co-creation as interaction between customers and companies in order to create value experience with product and to deliver unique co-created value. These experiences signify the quality of interactions and lead to positive relationships. Fuller, through his empirical study, highlighted the importance of co-creation experience and the impact it creates. Due to the diversified notion of user participation, the platform where they essentially collaborate plays a major role. Developing a co-creative platform has been unprecedented and has not been given much of importance till now. Some of the existing co-creation platforms include crowdsourcing and ethnography, such as blogs and blogs, which are all web and network-based, limiting users dialogue, access, transparency to the project, etc. On one hand, visual representations of a product or a design is proven to play a major role in anticipating issues and contributing to leading-edge solutions. On the other hand, it is also very well known that simultaneous work and real-time sharing can advance time and cost. Bringing all these aspects to an environment could overall improve co-creation. Virtual worlds for co-creation has been explored in the past, and it has been highlighted that a need for future research to compare traditional co-creation methods and explore how different types of virtual worlds can enhance creativity. And this served as a research gap to my PhD research. With advent growth of emerging technology, my PhD proposes XR technology as potential digital co-creation platforms with an objective to develop a methodology for co-creation using XR platforms and to determine a workflow and to check if XR platform can improve the efficiency and efficacy and support in creating value in the form of quality of ideas or novelty of ideas. In this almost 2 years of my research, I have performed a deep literature survey in the first year, followed by need finding and storyboarding in my second year, where I have developed a multi-user mixed reality environment, implementing the elements of collaboration and interaction within the environment. My final year is planned to execute one of the use cases with real users and evaluate the concept in any form. Apart from my PhD, I'm also been involved in a Horizon 2020 European Commission project called CASTLE, which abbreviates to Cabin Systems Designed Towards Passenger Wellbeing. In CASTLE, virtual reality solutions of the aircraft cabin interiors have been developed for evaluating designs during product development through human-centered design approach. Full-scale immersive environments of aircraft designs have been demonstrated to potential users, and feedback is collected from the user point of view. The idea for my PhD was emerged from this research by extending the VR to multi-user environment. Thus, an XR platform has been developed as a system where any 3D model can be imported to have collaboration and personalized interaction features. This system can also be extended for remote collaboration. A shift of collaboration from a flat one-dimensional experience to a multi-dimensional experience can be observed through this. In this context, a number of applications were built for different use cases. As in Project 1, virtual reality for cabin design, which is evolved to interaction features, as the Project 1 is Project Castle, which has been evolved with interaction features, for instance, in aircraft galley and lavatory for reachability and space assessment features before the manufacturing of the product. And this has been extended to multi-user environments, and multimodality of the VR has also been explored during this PhD research. In terms of a specific use case scenario, the XR system was developed for an aircraft galley design evaluation and assessment between a flight attendant and the human factors expert. Flight attendant, which is the user, and human factors expert, who is evaluating the task flight attendant performs in front of the galley. In the past, a human factors expert is always outside the loop unless the prototype of the design or the model is manufactured. Through this XR system or through this application, human factors is included in the loop to have an over-the-shoulder analysis of the product too. Thus, it is very crucial and to reduce the time and cost of the expensive prototypes too. Currently at TU Delft, I am involved to customize the XR system to a design evaluation of the staggered seats of Flying V. Researchers and professors of applied ergonomics and design at TU Delft made multiple designs for the new oval-shaped cabin with different seating options, for example, lounge chairs, group seating, collapsible beds, staggered seats, etc. Innovative seating of staggered seats has been designed by them, and I am expanding my XR system to help visualize the aspects of the model design to the stakeholders, that is to involve real users, especially in the scenario between flight attendant and a passenger. Thus, the idea is to involve a flight attendant, a passenger, a designer, and a human factors expert in a co-creative XR session to evaluate the seat model, and thus to evaluate XR system if it adds value for a co-creative session, and XR system, is it a place for co-creation, are the two main aspects to be evaluated here. Thank you, and any questions, welcome.
Let's thank the speaker. Do we have any questions to the speaker? Not really. So maybe then we'll move to the next speaker. Thanks again, Santosh.
Thank you.
So do we have the next speaker already lined up? It's online again?
Yes, good morning. Can you hear me?
Okay. Yes, we can hear you. Can we check the screen sharing?
Sure, 1 second. Can you see?
Okay, that looks good. So then let me introduce you quickly. So our next and last speaker for the morning session is Enrico Andrea Laviola from Bari, I guess, from Lab to Reality Optimization of Industrial Augmented Reality Interfaces. Please go ahead, the stage is yours.
Thank you for the presentation. Good morning. I'm Enrico Andrea Laviola, a PhD student from Polytechnic University of Bari, and today I will present my thesis work entitled From Lab to Reality, Optimization of Industrial Augmented Reality Interfaces. My thesis work is focused on the creation of guidelines for the authoring of the next generation industrial augmented reality technical documentation. As everybody knows, maintenance, assembly, and training instructions must necessarily be presented with the reliable technical documentation to ensure the safety of people, machines, and systems. Traditional technical documentation is a simple collection of work instructions, and much information is often conveyed from large texts or complex images, hard to relate to the working products. AR turns out to be an effective to support operators in manual procedural tasks. In fact, in AR technical documentation, AR work instructions can be registered directly on the real products, and the information can be chunked and conveyed from tailored visual assets, for example, CAD models, drawings, videos, and so on, with the potential improvement of operators' performance. However, there are also new issues in the authoring phase due to complex industrial requirements and a variety of visual assets. A misinterpretation of these aspects could lead to the inclusion of visual assets that require more authoring effort and are not suitable for operator usage, resulting in a performance reduction. Another important issue is that there is still a lack of expert knowledge of AR in the companies, with the limitation of the adoption of AR in the industry and the possibility of an augmented reality technical documentation with visual assets not optimized. From the analysis of the state of the art, it can be stated that companies would like to use AR for their technical documentation with a standard framework, but there is no agreement on the parameter to be used for the ARTD authoring. Some studies propose visual assets based on the operator's experience or preference. In other studies, the assembly task is decomposed into basic operations without a unique and standard method. In some cases, there is also discrimination about task complexity difficult to define. Also in the industrial context, there is no agreement in the literature about the best way to provide AR instructions. In fact, many studies on AR mainly focus on evaluating the concept of AR as such instead of paying attention to the information content. The absence of such guidelines results in the fact that an AR prototype tested in the laboratory is unlikely to be effectively used in a real industrial context. To overcome this lack concerning the augmented reality technical documentation authoring, we reached the conclusion that it is essential to provide standard guidelines following this research methodology. Understand how to carry out the decomposition of work instruction into elemental information. Understand how to convey information from visual assets and how to choose the most suited visual assets according to the working context. Therefore, the contribution offered by my thesis work consists in compensating lacks which are present both in the literature and the industrial context, focusing on the best way to convey an instruction in AR for manual documentations. The outcomes thus obtained will provide the guidelines to improve operators' performance, reduce the developer computational cost to companies in both programming and 3D modeling, simplify the authoring of augmented reality technical documentation, especially for technical writers not skilled in AR. In the next slide, I will present the current progress related to my main research during my year and a half of doctoral course. As anticipated, one of the main lacks in the literature concerns the absence of clear guidelines for the decomposition of work instructions into elemental information. Therefore, as first study, we propose a technique to help convert the traditional technical documentation into an augmented reality technical documentation. I mean to investigate what is the elemental information work instructions and which virtual content is recommended. We started from the method of tablets that represents a way to describe the motion involved in performing a task with a detailed list of the 18 tablets, such as search, find, select, grasp, and hold. Oiken et al. Further extended the method. Humans examine the environment and, based on information to start and information to end, can perform the action described by the tablet. Consequently, in an augmented reality technical documentation, each resulting information to start and to end could be conveyed through a visual asset. However, we observe that many of the information listed are similar, even if they belong to different tables. Thus, the visual asset could be the same. Then, in our work, we further extended the model proposed by Oekan, clustering the information to start and to end associated with different tables. As a result, we obtained 6 classes that we called information types: identity, location, way to, notification, order, and orientation. We applied the proposed information model from the case study of the assembly instructions of a model pickup truck. We presented to participants the 6 information types. Then we showed a list of visual assets and their properties derived from a literature survey on industrial interfaces. And we asked users to discuss the visual assets for every information type. In the first table, you can see the most voted visual assets for each information type. Interestingly, the 6 information types were enough to analyze all the instructions. Moreover, our work revealed that the use of product models in ARTD could not be generalized to all the instructions. In fact, even if previous works showed that AR interfaces based on product models are the most common, the most engaging, and reduce error rates, the literature also reveals some disadvantages for their use, with a higher cost in modeling, a higher authoring effort, and a higher quantity of information they needed to accomplish a task correctly. This last statement is important because redundant information does not necessarily improve operator performance, but on the contrary, it can be distracting and represents extra effort and cost for their modeling. Therefore, my second study concerns the visual asset optimization based on the information to convey. According to our proposed information types, situations may arise. A visual asset may contain one or more information types, or the information does not require the use of a visual asset and can be obtained from object affordance or operator experience. Therefore, we extended the information types model by including the combination of multiple elemental information that compose an instruction. We propose a novel authoring approach based on Norma's definition of affordance signifier, according to which the task complexity is established by the amount and type of information needed to correctly accomplish the task, included in a work instruction. This information can be provided from object affordance and AR signifier, one or more visual assets with their properties. Our model is called minimal AR, where the information provided from AR visual asset is the minimum needed to accomplish the task, regardless of object affordance and operator experience. In augmented reality technical documentation, the choice of AR signifiers is critical for operators, since they can cope with 3 different scenarios of information to convey: incomplete, minimal, and redundant. In our user study, the hypothesis is that compared to the minimal AR signifier, user performance, completion time, mental workload, error does not improve with those conveying additional information. For this purpose, we design a Lego-based assembly task that can well simulate industrial assembly. Moreover, as you can see in the table, it is possible to easily modify many variables, such as quantity, order, and shape, with a progressive increase in complexity in accordance with the industrial manufacturing requirements. We involved 40 participants in our user study, which results support our hypothesis that there is no advantage in using AR signifiers that convey more information than the minimum signifier. Then, from our study, it is possible to propose the use of minimal AR approach as a preliminary guideline for choosing the most suitable visual assets in ARTD to avoid information overload and excessive authoring effort. The theory concerning the choice of visual assets for ARTD as minimal AR is not a simple process, especially in a real industrial context, because AR depends on many factors that differ according to the working context and need to be considered at the same time, such as environment, lighting, blind areas. In our more recent work, we have studied also this last constraint. Blind areas could make inadequate the minimal AR approach. The visual obstruction of components and the relative AR instructions in blind areas, in fact, may generate a loss of information. Previous studies already focused on assembly tasks for the comparison in blind areas of different AR signifiers. However, the results obtained for assembly cannot be applied to maintenance, which is more sensitive to the problem of blind areas when the machine is already fully assembled. To fill this research gap, in our study, we evaluated 3 AR presentation modes to convey maintenance instructions in blind areas, measuring user performance. We investigated solutions as in-situ content with X-ray techniques, side-by-side content, and virtual mirror. The experimental outcomes derived by this study may serve as preliminary guidelines, but further studies are needed. In future work, we plan to test the validity of our minimal AR authoring approach in real manufacturing case studies. In addition to our previous studies, we also intend to consider the combined effect of object affordance and signifier on user performance in a real industrial scenario. Another study to be conducted will include the effect of operator experience on the choice of visual assets. In fact, depending on the work skills, different combination of visual assets may be required to convey the minimum information needed to accomplish the task. Another topic that would be interesting to explore concerns the choice of visual assets between those with the same amount of information provided. Unlike our minimal AR authoring approach, in which the choice of the visual assets depends only on the quantity of information they can convey. Another topic is about the amount and time of effort that the user must put into understanding the information conveyed. This variable may conflict with the one concerning the quantity of information, so it will probably be necessary to find the right compromise. Finally, the possibility of creating guidelines for the authoring of augmented reality technical documentation in real industrial context will also allow me to carry out concrete assessments of the economic impact that AR can offer for the companies. So I finished my presentations. Thank you for your attention.
Thanks to the speaker. Do we have any questions for the last speaker? Guillaume?
Well, thanks a lot for your presentation. Very interesting topic. I was just wondering whether you were somehow restricting, if I can say so, to visual assets, or do you consider other types of assets, including sound feedback, for instance?
Thank you for the question. We are considering visual assets such as text, drawings, technical drawings, 3D models, video, also with sounds. So every kind of assets that can allow users and operators to understand the information. Also notification, for example. For the notification, also we tend to use a symbol, for example. The standard symbol that you can find also in every manual. So.
Thank you.
Thanks. Do we have another question? If not, then let's thank the last speaker again. So the next step is the long-awaited coffee break, followed by the first session of one-to-one mentoring. For that, we have a mixture of on-site, online, on-site, basically all combinations. For the mentors and students that are on-site, I hope we have communicated that clearly. You're welcome to use this space or distribute around the, let's say, lobby to find a quiet space to talk to each other. For students or mentors who are online, there is a setup in GatherTown where you can meet. Also, we are asked every student to set up their posters in GatherTown. If that helps discussing that, you're welcome to use it on site as well, obviously. If you have any problems connecting to your mentor or to your student, please let us know. We'll try to help you out. And after that, we'll have the lunch break. And at 2 o'clock, we're back here meeting with the second batch of students and mentors. So thanks everyone for participating in the first round, and I hope you enjoyed it so far. Thanks.
Okay, so let's start it. So hello and welcome again to this session of the Doctoral Consortium. So Ulrich and I, Cedric Fleury, we are the two on-site co-chairs of the Doctoral Consortium. We also have two other co-chairs that could not be present today, so Czech Tiantan and Antonio Uva. So for those who were not attending the morning session, I will just do a quick summary of the opening presentation. So the goal of the Doctoral Consortium is to provide opportunity to PhD students to present their work and receive feedback. And also, of course, to receive guidance from mentors who are experienced people from the field. We also hope that it will give them an opportunity to build a lasting connection with the mentor. So the general format for this afternoon session will be exactly the same than for the morning session. So we will start with a short talk from each of the 6 students that are presenting in this afternoon session. And then we will move to one hour mentoring session where a mentor will provide guidance and will discuss with a student. So in very short, we had 13 submissions and we select 12 papers. We get a bunch of students from Europe, but also 1 student from the US, 1 from Singapore, and 2 from Australia. So we are 4 co-chairs for this doctoral consortium, and we select 12 mentors for 1 for each paper. So now we move to the schedule of the afternoon session, and I maybe let Ulrich introduce the first speaker.
Okay, so hi everyone. My name is Seth Grace Banaga. Can you hear me properly? Yeah, okay, good. Yeah, my name is Seth Grace Banaga, and I am a PhD student from the School of Computer Science and Statistics at Trinity College Dublin under the supervision of Carol O'Sullivan. My funding institution is the Real under Science Foundation Ireland. So my project is on stroke rehabilitation through proxy agency and embodiment in mixed reality. So there are 3 keywords in the title of my project, that is proxy agency, embodiment, and mixed reality. So for those people who don't know proxy agency, it's given a person a sense or feeling of control over their own body and making them feel like they are affecting the environment. Embodiment is being inside or controlling a body, and mixed reality is the combination of both VR and AR to create an environment where physical and digital objects coexist. So just a bit of background on my my project. The problem we are trying to address is if an individual has a disability or is confined to restricted spaces, it's quite not possible to give a sense of agency. So more on the motivation, the inclusion of VR, AR, MR, and other technologies in the rehabilitation process of patients with chronic conditions such as stroke has been significant in recent years. Gamification, that is the strategy of engaging users by including game mechanics and point scoring and leaderboards, is widely being used in medical treatment and in rehabilitation. In this work, we identified patients recovering from impairments due to stroke as our target users. The reason for this is because one of the leading causes of death and disability worldwide is stroke. To address this problem, we want to use an MR approach and create a dance exergame application to aid in their rehabilitation. Now, this will involve animating the dance motions of an embodied virtual avatar and allowing the users to control this avatar using a variety of devices such as VR headsets and wearable sensors. The method of proxy agency will be delivered through a virtual dance trainer in the exergame application, while the embodiment aspect will be achieved when the patient uses the application to control the dance motions of this agent as if they own the body of the virtual avatar. Through this application, we intend to find out how embodied the participants feel, as well as measuring the level of agency and preserving and improving their cognitive and motor functions as extra benefits. So just on literature review, the key topics I looked for is on agency and embodiment, character control and puppetry, gamification and rehabilitation, and other related works. Just stuck on time there. Let me just move on quickly to the current work I'm doing. Initially, I The first thing I did was to learn capturing dance motions using the Vicon motion capture system in our Trinity lab, and learning how to clean and retarget these motions to a virtual character using Motion Builder and Unity, and controlling the captured dance movements using the Xsense dot wearable sensors that we purchased. Yeah. So Xsense dot sensors are wearable sensors that are used for precise motion tracking. So using wearable inertial sensors to track everyday human motion has been a popular approach for classifying and recognizing human activities. In this initial stage of my work, we attempted to use a recurrent neural network approach to classify simple dance arm motions from the accelerometer data that we received from the Xsense dot sensors. In this work, the limitation of it is that we only use 2 sensors in this capture. So when I tried to submit this work, we failed to get it published because I only received a 60% accuracy rate, and yeah, so perhaps we will receive a more accuracy rate if more sensors were worn on different types of body parts, as they were only applied to the wrists. For this work as well, we wanted to control the motions of the virtual avatar using the sensors. However, there was no plugin for Unity using the sensors, so we tried to integrate it using the Kinect Z app, and we are currently working on this approach. So ML Agents is an open source plugin for Unity that allows developers to create realistic environments and where you can train models. Agents can be trained using reinforcement learning and imitation learning, but for this project, we are focusing on imitation learning. We plan to perform live experiments to capture the patient's restricted simple dance movements, learn a mapping from these captured motions to the motions we wish the user to perform, and apply them to the virtual character using the imitation learning approach. Imitation learning basically just teaches the agent how to behave, and it learns by imitating the behavior that the player demonstrated, instead of trial and error as reinforcement learning is. So yeah, for my project in Unity, the user will input their motion with key press, and the demonstration recorder will record this, and it will train a neural network driven agent to imitate the user's selected motions provided in the recording stage. After training, the results will be applied back to the agent, and a predicted set of dance motions will be visualized on the proxy agent virtual avatar. Okay, so in a nutshell, this is what the Dance Exer Game app should be. Our plan is to show our participants a piece of simple dance choreography that they can follow. While performing, participants will be wearing the sensors and the suits so we can capture their movements and learn a mapping of their motions. From these mappings, we will predict the sense of dance motions and apply the imitation learning approach that I mentioned in the slide before. And essentially, if the participant raises their right hand slightly, they will not see a reflection of their actual movements, but rather a virtual avatar performing a more complicated dance move using the right hand. 3 levels of dance sequences, beginner, intermediate, and advanced, will be provided to users over the course of 6 weeks. And patients with varying levels of stroke impairments can choose to start at the beginner level and work their way up to intermediate and advanced levels. Once they have completed the level, the dance choreography will gradually get more difficult. So for future work, we intend to collaborate with a variety of stroke therapy stakeholders, such as stroke patients and specialists and experts to oversee the system and provide their honest feedback and assistance so we can improve and tailor the Exergame application specifically towards our target users. We have actually been in contact with Juliette Hussey. She's from the Department of School of Medicine in Trinity. And the current work on the Dance Exergame plan was in talks with her actually. So we sorted out this plan at the start of the year, and we are currently just creating the application now. The rest of the future work involves capturing more motions, improving the current work that I've been doing on the XSense dot sensors and ML agents, and finishing creating the Exergame application. We'll also conduct several focus groups and user studies with stroke patients, and patients with mobility impairments will be conducted to determine the level of difficulty of dance patients will be able to perform, type of dance they would be interested in learning, and their feelings and thoughts about using VR headsets and other technological device for this project. So our ultimate goal is to support patient intervention with pre and post hoc evaluations to determine the clinical efficacy of this approach. So just to conclude, the new contribution of this project is in the way that a virtual character is controlled, using wearable sensors and mapping from the user's restricted motions to control the dance moves of the avatar. And we believe that this will be beneficial for our intended users, that they will be able to see the results of their motions and improvements in their mobility functions over time. So yeah, that's my project. And thank you so much. I'll be answering questions now. And if you'd like to get in touch with me, my email is panagas@tcd.ie.
And thanks a lot. Let's thank the speaker. Do we have any questions? A second.
Hi. I really like the topic. So I just have a question related to if you have looked around in state of the art, in particular, not in dancing activities, but in my knowledge, there is a lot in other fields like sports and rehabilitation as well.
Yeah.
So the literature, so there is a lot of literature in that. So my suggestion is to, if you have done a deep review, not only in the specific topic, but also in other. Thanks.
No, I've only been focusing on dance because actually my previous work in my final year project, I created a dance training system, a hip hop dance training system. And I'm building on top of this work for my PhD project because I had the same supervisor in my undergrad final year project. I was in talks with Juliette Hussey and one of her students as well is doing it on sports as well. And in DCU, we are in talks with other students. Luz, I forgot her last name, but in D-Real, there's a lot of people working in rehabilitation, and there's other students working on sports, and mine is on dance, which is a novel approach because not a lot of papers were published based on just dance rehabilitation. There are more on gait analysis and more on sports as, yeah.
So maybe focus, focus in your presentation what is particular in dance compared to other activities that you mentioned right now. And eventually, in my experience, I remember that there are some activities, sport activities that are very near to dance, like some martial arts or some activities. So maybe just to catch some of the background, that's possible a good advancement that you can quickly have.
Okay, yeah, thank you so much.
You're welcome.
I'll keep that in mind.
So we have another question from Bruce.
Thank you very much. First, I just want to make sure I'm getting this right. So the patient does a simpler motion.
Yeah.
And then they're shown a more complex dance
yeah.
motion.
Yes.
Okay.
So like if you're a stroke patient, you won't be able to move like your whole body. So like if a patient just moves like just a small part of their body, what they would see on the screen is a more elaborate dance move. So yeah.
So okay, so I guess my question is these movements, I guess it's two parts. One is, are the movements themselves prescribed by the clinician, so the physiotherapist, whoever's doing it? And second, what's the feedback that they're not doing the movement correctly? Or is it that you just want them to move?
So when I was in talks with Juliet, I would be providing the dance movement, or our choreographer would be doing, would be capturing the movement, and they would be copying it while they're performing it. So there's not, we've only been in talks with her. We haven't been, it's not set in stone yet, but sorry, I paused there. Yeah.
It's just that some stroke rehabilitation is that you want to, okay, I want to be able to move my hand like that.
Mhm.
So then what it does is it's sometimes what they do is they'll give visual feedback to kind of encourage you to do more.
Yeah.
But the actual movement is the clinician tells the person, I want you to move your hand like this or move your hand up, as opposed to just moving your arm in any direction. Is there?
What we're thinking of is giving like a prompt on the screen telling you to move. Is that what you meant, or?
No, I can talk to you afterwards.
Okay, yeah, okay. Yeah.
So we have another question here.
Thank you, and thank you for the interesting presentation. I was wondering if you only considered standing up motion, or like what about if a patient is laying on a bed? Yeah. Do you also consider this use case? Like if he's lying on a bed, will he see, with this person, see himself or herself dancing, standing up? Do you handle that case, or is it other person has to dance?
Actually, what we were thinking of, we know that the patients would be for this project would be sitting down. So
sitting on a
sitting down,
okay.
yeah. So they would be doing the movement sitting down, but what they would be seeing on the screen would be them standing up and performing the dance.
And performing like moving around, like or more like at the same place.
Yeah, it's more of a simple dance movement. It's not
Okay.
like like grand movements. So
because then maybe there would be some motion sickness, or if they like move too much around, I guess. No. But thank you.
Thank you. Do we have another question? Okay.
Thank you so much. Yeah. So just a quick question. The title mentioned mixed reality, but what you were presenting appeared more like and you mentioned that it was a virtual reality. So just wanted to understand what the differences were. Why did you choose MR instead of VR? And any kinds of benefits that between each of the media, because that will also affect it, as you know that VR, there's a higher sensation of simulation sickness, and with a patient already suffering from something. My other question, the second question, is also similar to the previous question, as it working with stroke patients. I'm just thinking about the previous project that I used to do. How is it prescribed by the clinician, and what is the mapping between the dance move and what's needed to be done? Because again, it really depends on the patient and how that will benefit the patient. So there are certain exercises that are normally done by a physiotherapist, and how does that map to the dance move that will benefit the patient, that most probably you'll need to take a look in terms of like the medical benefits, right? I mean, I don't claim to be an expert in this area, but you might want to check with the experts or the clinicians or the physicians.
So just to answer about the virtual reality and mixed reality. So we wanted to finish off creating the app first on Yeah, and then adding on the virtual reality aspect of it. I'm currently working on applying this app with virtual reality. So why I chose it is because why I chose mixed reality. Mixed reality is part of the project title that was given to me. And yeah, so I have to do it. As for virtual reality, we were given Meta gave us the Oculus Quest to work on, so I'm working on that for this project. And I know that for stroke patients, it could be difficult to use VR since there is like drawbacks of like motion sickness and everything. But yeah, that's why we have to get in touch with Julia Tussi from the School of Medicine to advise us on appropriate measures we can take for this project.
Yeah, okay, maybe we'll discuss that offline. Yeah, but thank you.
Thank you so much.
Thanks a lot. Do we have any more questions? Then let's thank the speaker again. So the next speaker will present online. Can we just make sure that this is all working? Okay, perfect.
Yes, can you hear me?
Yes, we can hear you. So just one sec. So the next speaker, I guess from Germany, is Christoph Holtmann, with his submission titled Cross-Reality Authoring, a Mixed Reality Editor Approach. We can see your presentation on the screen, and when you're ready, please go ahead.
Okay, yes, thank you. Yeah, good morning, still good morning from Berlin, Germany. I'd like to present you my PhD topic, Cross-Reality Authoring, a Mixed Reality Editor Approach. I'm from the University of Applied Sciences in Berlin, HTW, and my research is in the field of XR technologies, human-centered, user-centered design and human-computer interaction. And over the last years, I had the chance to be part on several multi-user mixed reality experience projects, like you see on these pictures. And in the last year, I worked together with artists on a project for an immersive installation for an exhibition in Berlin. And the artist wanted to use the HoloLens device to create an immersive experience, but the problem was they had no experience with software like Unity to author or edit the content. So what me and my team did, we designed an editor for the HoloLens device, so the artists could use just the device itself, so the target device, and my team and I later on transferred all the content and prototypes to the Unity engine. We added some interactions and then built the application so the experience could run smoothly on the device itself. The problem was we had to do this by hand. And I'm still in the early stages of my PhD, but the idea is to develop a way or a concept that combines the different platforms. So on the one side, the Unity engine, an advanced editing tool on the computer, on the PC, and on the other side, an editor on the target device, this time the HoloLens. And so therefore, data needs to be synchronized. Also, interactions need to be synchronized, and especially the UI and the processes needs to fit. And so the two devices can be part of one authoring process. There's research on this. For example, by Kraus et al. They interviewed mixed reality developers regarding their challenges and issues when it comes to the development of immersive applications. And one thing they mentioned, for example, is that it's really complicated to design a 3D immersive interaction on a 2D screen. So you cannot test it, you never see how it really works in the end. Ashtari et al. Defined 8 key barriers when it comes to AR and VR, the design of AR and VR applications. And one thing, for example, is that the current authoring process or development process for experiences is split multiple processes. So you have a planning phase, you have the actual design and implementation phase, you have the testing phase, and often you need to use different tools and procedures to achieve your tasks. And yeah, you don't have one design process in the end. And this is also the case because the target device is separated from the current design or authoring process. Based on this, I did my own interviews with mixed reality developers, and I got very similar answers, but also ideas on how the target device could be better integrated into the process by using the sensors of the device itself and the functionalities like hand interaction, for example. When it comes to the principles that need to be I need to take care of when it comes to the design of the bridge between the two platforms. It's important that, for example, information that is required by the authors is available whenever they need it. So on both the devices, information that is necessary needs to be available. So there need to be a good synchronization, and also the transition between the devices needs to be very smooth. So the target device, for example, can invite the author whenever or as often as possible to use the device itself to get a better understanding of how the user experience will feel like in the end, and not just have the author or developer perspective all the time. There's lots of research on cross-device experiences when it comes to different device types, how to bring these together into one experience, how to interact with each other using different input devices. But what I haven't found yet is concepts for the authoring process, especially when it comes to mixed reality, and when it comes to that the target device is part of the development process. So you can switch between an advanced tool like Unity and the HoloLens, for example, whenever you want. Once again, my approach, the idea is to connect the current development platform with a target device. And how to do this, I want to bring the advanced tools from Unity to the target device in the first step, to enable developers and authors to use the target device itself to create the experience. But on the other side, there should be a connection, so you can still use the Unity engine or a different advanced tool for tasks you don't want to accomplish, or you cannot accomplish using the target device. This is a really huge area. There's lots of different research topics related to this. So my focus should be on the connectivity between the platforms, focused on professional authors. And when it comes to the context, the scope should be limited to physical connected and room-filling scenarios. And I don't want to get too deep into technical things like algorithms and other technical challenges, but I want to focus more on UI and UX, and especially the transition between the platforms and usability for the authors. And later on, generalization is, of course, important when it comes to abstraction, using the concepts, for example, for virtual reality applications. These are my research questions, and I know I have to refine some of these, but right now I look into the needs and challenges, and especially the procedures of the mixed reality development process. And like I said, I want to focus on UI. So for me, it's important to find answers to how advanced tasks so especially advanced tasks can be transferred from a computer, the Unity engine, to the target device and the editor I developed. So my next steps are additional interviews with mixed reality developers. I want to do a better evaluation of the current approach, my mixed reality editor, and I need to refine the research questions and also the user studies. And based on that, I want to develop my first low fidelity prototype, and in the beginning of next year, the first technical prototypes should be developed. These are my references I used for this presentation. And yeah, this is it for this presentation. Thank you so much, and I'm looking forward to your questions and the discussion.
Thanks, the speaker. Do we have any questions? No? Michele?
Again, state of the art. So some second presentation, which maybe for time doesn't give at least one glance of what has been done till now. You know, a new researcher should know that VR, AR has been studied since 40 years right now. So this as maybe we didn't change the world in the past, but we actually tried something. So I invite you to look around. The problem you are talking about have been addressed maybe in a different way by many research groups and papers. And yes, there is still a lot to do. So my question is, have you tried to do a systematic review on the topic?
Yeah, I just started, but I'm on this, yes. So I definitely need to do more research in this field, and also systematic review in a more advanced way than I did it yet.
Anyway, the topic is very interesting. Is the reason why we don't have many augmented applications. There were other similar proposal in the morning, so maybe you can even look at some other students. Maybe you can find a topic, create a group, kind of group of interest, because now I think we need also to facilitate some interest groups, because I see there are some interest groups, and this will be very effective to do better research. Okay, thanks.
Yeah, really good idea. Thank you so much.
Do you have any other comments? If not, then we'll thank the speaker again, and we'll move to the next speaker, who will be online as well.
So I hope you can hear me well.
Yes, we can hear you, and we can see your screen share, or at least the camera for now. So
Yes.
Let me announce the next speaker. Next speaker will be Sebastian Kepler, and he's presenting his work. Let me just get this right. Collaborative manual tasks in distributed virtual environments. So for now, we cannot see the screen. Okay, yes. Looks good. So the stage is yours.
Okay, so we stay in Berlin, but we jump from the augmented reality into virtual reality. So hello, everyone. Welcome to my presentation of my PhD topic, Collaborative Manual Tasks in Distributed Virtual Environments. And first of all, English is not my native language. That's why I want to apologize in advance for my pronunciation. So let's start a little bit about myself. I'm Sebastian Kepler, and I'm a computer scientist from the HDW in Berlin, Germany, as well, like my colleague Christoph in the previous presentation. And I mainly work and being interested in the field of virtual reality and how we can interact within the virtual environment in a natural way. That's where our hands come in play, and because it's a so strong tool that enables us to naturally interact and explore our environment. But I'm also interested in how we could manually interact with others together in these virtual environments. And as you can see from the title of my topic, that manual collaboration plays a major role in my PhD thesis. But what is manual collaboration actually? Manual collaboration, or collaboration in general, is defined as a joint action. I will not go too deep into this slide because of the time, but to sum it up, a joint action involves at least 2 participants which share a representation of a goal and each other tasks. And during the process, we monitoring each other and ourselves to predict everyone's action, to coordinate accordingly to successfully accomplish this goal. Now, if we talk about manual collaboration, there are mainly 2 types of manual collaboration, which are the first one, shared object manipulation. So, for example, when we take a big object like a table together and move it somewhere else. And the other one, which my PhD is mainly focused on, are the handover object transfer. So if we look into handover tasks, we can divide them into 2 phases with 2 agents involved, namely in the role of a giver and a receiver. While they share a common goal of successful transferring an object, their tasks in this process are different. The specific tasks depend on the time and phase in the phase here. So the handover phase, all of the communication between the giver and the receiver, the grasping and the transport is happening, followed by the physical handover phase, which starts once both agents are in physical contact with the object. In this phase, the modulation of forces, such as the grip force, happens. Here, the main task of the giver is to guarantee the object stability so it's not falling down, while the receiver is in charge of controlling the speed of force modulation. So the grip force from the giver decrease, while the receiver's grip force increase until it's completely released. The research about handover tasks already have found out that this physical handover task or the physical handover phase is completed within approximately 500 milliseconds in reality, which gives already a guess of how fast it could be done. So when we bring this into the virtual reality, there's actually an issue. When we try to grasp in virtual object, we usually just grasp into the air, so we miss any haptical feedback. This is already a problem in single user interaction, as you can hopefully see in this animation. The finger is penetrating the button deeper than necessary due to the missing DES information. So in reality, for handover tasks, we don't really think much about giving someone an object. It's an implicit process that happens nearly automatically due to the experience we have gained in our life in performing this interaction over and over again, which itself is based on the sensory feedback we get. But once this sensory feedback is missing, the interaction can become really hard, frustrating, or even fail. So to overcome this problem, we can use sensor substitution to compensate the lack of haptic feedback. There's already some research about in providing visual feedback in 3D grasping interaction, with the conclusion that users prefer having visual feedback than no feedback at all, and that visual feedback can enhance user experience and the performance. And visual feedback opens us ways to encode information and deliver it to the users, which they normally wouldn't have, such as the grip force. Pressure Bird, I hope I spelled the name correctly, and Burst made an evaluation of this visual feedback during virtual grasping, which you can see in the upper picture. The results are that users prefer realistic behavior during the virtual grasping, like the outer hands where the finger's not penetrating the object surface. Interesting, this performed worst, while the inner hand visualization performed best, but this wasn't preferred by the users. And so the compromise by using visual feedback, such as the finger color and the object color, this was most liked by the users. A similar evaluation was done by Canales et al. where they executed this experiment again with the addition of reactive affordances that you see in the lower pictures, with similar results that providing information about the grasping state are preferred. It is also mentioned that this studies only research about single-user virtual grasping. There are no studies about multi-user handover task in virtual reality yet, where my PhD thesis aims for. So I have searched for 2 years and I didn't found any evaluation about it. But the idea of my PhD is not only to look into the effects of visual feedback during handover tasks, but also include other sensor modalities like the auditive and vibrotactile feedback by providing suitable stimuli, and to look how it can improve performance and user experience in handover tasks. And to investigate this, there are 3 consecutive studies planned, with each answering questions about effects of a certain sensor modality. So this first study will focus on visual stimuli, which results are used in the second study, where the effects of auditive feedback will be investigated and how a combination of both influence performance and user experience, which results itself will be taken into a third study where the haptic feedback will be added. Each study contains also a pre-study where preceding questions will be answered. An example for the visual feedback, how embodying virtual avatars can improve handover tasks. So if there are not only hands flying around, but if you have access to more information channels like such the gaze of your partner's body. And this leads also to questions about how visual attention is distributed during this handover tasks. So do they look at the partner's face, their hands, the object, or even somewhere else? This could help to design suitable visual feedback, which brings me to my experiments. So as you can guess, the experiments involves 2 participants per session, where each one is wearing an VR HMD, and we track their whole body, including the hand and finger tracking, and this is done by our motion capture system. We use Capture for this, and the task is to exchange virtual objects between each other with their virtual hands. So the giver is picking up an object from their side, transport it into the reach of the receiver without putting it on a surface or a table, and the receiver has to grasp the object from the giver's hand and transport it to their own side. Then the roles are swapped and the process starts again. To give a little bit pressure, there will also be a time limit of 3 minutes, and within this time, there need to be as many object exchange as possible. So I already come here now to my conclusion and the next steps. So my PhD thesis is about to find out about the influence and of the different sensor modalities in handover tasks. And to investigate this, there are 3 studies planned, which will give an answer to the presented research question. Right now, I'm in preparing the first study to substitute haptic feedback within the visual stimuli. On the right side, you see the virtual scenes, which will be used. In the upper one, there's the preparation scene where the users or participants can get familiar with the scene and try out the grasping interaction. And down the experiment scene where the participants will see each other and doing the experiment in exchanging an object. I already know that the given tasks in the study are pretty generic, so later I will also work on a realization of a concrete use case, such as training simulation of surgery or machine assembly scenarios. And which brings me already to my end of my presentation. So thank you all for the attention, and I'm happy to hear your questions, feedback, and suggestions. Thank you a lot.
Thank you. Do we have any questions or suggestions from the audience? Yeah, let me give you the mic.
Right. Thank you for the talk. Just curious, how do you consider do you consider latency in the application? Because you talk about distributed virtual environment. So I wonder if latency is a concern in terms of the efficacy of the different modality of interaction that you are considering. Thank you.
Yes, thanks for the question. Right now, I have to admit that we not have an idea about the latency yet and how it will behave during the interaction. That is something what we want to try out in the first pre-study too, when we just look into how the interaction works with avatars and the visual attention. So if we will notice the latency, this will also take into consideration considering designing the visual feedback.
Okay, we have another question here.
Thank you for the presentation. I was wondering, because it seemed like the task in the end resembled a lot like a picking task, and like over which there is a lot of related work, I think, in terms of just 3D interactions methods. And I was curious in how being with someone else, like doing this interaction with someone else, really had an impact on what you want to observe. Because I'm just wondering, like, if you're interested in exploring the feedback you observe, like we want to observe the audio feedback, the tactile feedback, what difference would it make to do it just like grabbing a sphere alone compared to really giving it to someone else or taking it from someone else? Well, like, or do you consider as well to add some feedback if the other like has it already, or if you have it at the same time, or so, something like that? I don't know if it's clear enough.
So the main idea is to provide or make it possible that we can have a, let's say, nearly natural, realistic interaction with each other. And in a lot of training simulations where processes are trained, there are often this interaction, like in surgery situations, where they have to train giving a special knife to each other, where it has to be timed. This need to be done in a proper way. And because of the lack of haptical feedback, we already missing something in the training simulation. And to make training this and to give some feedback to help the users exchanging an object, we want to find out how this impact of giving this kind of feedback, if this answers your question.
Yeah, I'm just somehow I'm just wondering how like grabbing an object from someone's hand is very different from grabbing it from a table. It's very little detail, but I wonder how like this having another person involved, like how it impacts the. Because there is already like there's some research. I think there is a paper about this, the effect of sound feedback when you grab an object. So now, what would you bring, like adding this in the context of grabbing it from someone's hands? But I don't know. I think we can maybe discuss it not in this conference then, but offline at some other moment.
Of course, I would like it.
Thank you.
Thank you. We have another question from Kiyoshi.
Thank you for the interesting presentation. I was just wondering if you are also looking into the relationship between the participant's perception and the realism of the appearance of the object. Because I think, for example, if you see a very photorealistic rock, it will be very annoying if those rocks penetrate into another object. So I also looking into some kind of relationship between the appearance and the perception.
Do you mean the relationship between the participants? So if they are friends, or so the social relationships they have?
Yeah, so you are investigating the the appearance, the vision and auditory and the tactile feedback when you're handing over some object to the other person, right?
Yep.
So yeah, so I just thought that the perception would be very different if you see a wireframe object, a photorealistic object, or something.
So right now, the experiment just are planned simple cubes in a way. So that's somehow where we have to concrete the use cases too. So in the later iterations of the studies, there might be not cubes, but all knives, for example, or some other tools that can be handed over. And in this case, of course, right now the photorealistic approach should be focused on the scene is already looking photorealistic. So I want to keep that style, so it's not break the appearance.
Okay, thank you.
Thank you, Kiyoshi. Do we have another opinion or question? So if not, then I'd like to thank the speaker again. And we're moving to our third speaker online. Do we have Marina lined up? Okay, we can see the screen. That's good. So our next speaker will be Marina Ricci from Bari again, with the title Enhanced Shopping Experience in the Fashion Industry Between Interaction and Perception. So please start whenever you're ready.
Hello, everyone. My name is Marina Ricci, and I am a PhD student in Industry 4.0 at Polytechnic University of Bari in Italy, supervised by Professor Michele Fiorentino. Currently, I am a visiting PhD student at the Technology University of Delft in the Netherlands. And in the next few minutes, I would like to introduce to you my PhD topic, exploiting virtual reality for enhancing the shopping experience in the fashion industry between interaction and perception. First of all, it is relevant to state that my research topic intertwines three different research areas, starting from the design for interaction, because it relates the design of user experience, user interface, and interaction behind the applications to be developed. Computer science, since it exploits VR technologies for the development of these applications, and also marketing, since the research field is the retail industry and the customer and retailers' patterns. Starting from the definition of the background of my work, I can state that nowadays buying a product online is no longer about the product itself, but more the experience it could offer. And also the retail industry needs to explore new technologies that could improve digital shopping experiences and also enrich online consumer experiences in the emerging metaverse. In particular, in today's global economy, fashion is one of the retail sector that could really benefit from VR. Also, the fashion industry is growing at a very fast pace with an expected compound annual growth rate of 11.45%, resulting in a projected market volume of $1.37 trillion by 2025. And the use of retail technology in the fashion industry plays a key role in enhancing the user experience. Although virtual reality represents one of the most interesting technologies and a perfect candidate for next generation e-commerce, the literature on VR in fashion industry is still quite fragmented. However, we identified the issues related to online shopping experiences by categorizing them with respect to the point of view of customer and retailer perspective, starting from an analysis of the scientific literature to unveil these issues. And although VR has proven its effectiveness in the field of fashion retail, the scientific literature is scattered and still presents limited studies. In fact, there are only few experimental design, and for this reason, further research is needed in order to assess how VR technology could really improve the user shopping experience. In fact, from our identification of issues, we can see that from the customer side, the main issues are the impossibility to configure the end product and also the lack of touch inside these kind of experiences. Instead, from the retailer sides, the issues are inventory cost and also store cost related to real estate, and also the need to reduce the wastes in garment production. But what is the research objective of this PhD topic? It is improving the user shopping experience in the context of online shopping for the fashion industry by exploiting VR technologies. All the aforementioned issues were analyzed and processed to design some solutions, and so my research topic could be divided into two parts. The first part is about conducting a comparative study between one shopping experience in desktop virtual reality and one developed in VR. In fact, since the literature in the fashion industry is fragmented, contribution in this field present both immersive and non-immersive VR experiences. And so we choose to first conduct a comparative study. The comparative studies in the literature in the field of retail industries are only 6, and in other product areas such as groceries. And so this would be the first comparative study in the field of fashion instead. And this study so want to explore whether using VR technologies enhances the shopping experience in the fashion industry compared to desktop virtual reality. The second part instead is currently in progress and concerns the implementation of pseudo-haptic effects within an online shopping experience with VR technologies. With this application, we aim to explore the feasibility of recreating the sensation of people's actual touch with fabrics through a visualized touch on a user interface. The first part of the research about the comparative study presents this preliminary research question. Is the time of shopping experience longer in VR than in DVR? And also, can the proposed VR-based shopping experience deliver higher rates in terms of hedonic and utilitarian values than the DVR-based? Can the proposed VR-based shopping experience present a cognitive load comparable to the DVR-based? And at the end, can the proposed VR-based shopping experience give a better user experience than a DVR-based? From these research questions, we conducted a comparative study between VR and DVR shopping experiences by conducting a within-subject experiment with 60 participants. The DVR mode consists of a desktop computer setup using a mouse and a keyboard for navigation, while the VR mode consists of the use of an head-mounted display and controllers. Instead, for the task, participants have to find a bag in the virtual shopping store and to explore its features until they were ready to purchase it and to click on the shopping cart. As post-hoc measures, we consider to measure the time duration of the experience, the hedonic and utilitarian values, the user experience, and the cognitive load that were compared in both the experimental setup. And as we can see, these are two photos, two figures related to the comparative study in which the user is experiencing on the left the desktop virtual reality bag shopping experience, instead on the right the virtual reality shopping experience. We, of course, made some hypotheses that were about VR shopping delivers higher hedonic and utilitarian values than DVR. VR shopping improves the shopping experience and the user experience. The cognitive load in VR does not differ from that in DVR, and the user stayed immersed for longer in virtual reality than in desktop virtual reality. As a result, all hypotheses were tested and also confirmed. For the second part of the research instead, I can say that it is still in progress since it is being conducted in TU Delft and is about pseudo-haptics for fabrics perception in online shopping, formulating the following research questions: how pseudo-haptic effects can be applied to fabrics with VR, and how do pseudo-haptic effects on fabrics affect the user perception in a VR shopping experience. As a first step, I'm trying to recreate haptic fabric properties such as compliance by using mouse inputs and variation of the speed to convey an harder or softer perception of the material. We are currently using as a first experiment a progression of 60 photos previously taken with a professional setup, and then we aim to transfer this application by exploiting VR technologies. Here is the Gantt chart, including all the planned doctoral tasks. So starting from the state of the art until the bypassing from the two parts of my research until the final thesis of my doctoral path. And considering the future works of our research, we plan to test first of all, the DVR and VR experiences also with direct customers from a specific fashion retailer. To increase presence by implementing avatars and virtual mirrors in the experiences, to replicate the comparative study also for other fashion products such as clothes and not a bag that is an accessory. And at the end also from the second part of the research, inputs to create a library of visual materials to be embedded in online shopping experiences. To conclude, this study has implications for the fashion industry research, as the use of VR can potentially lead to novel shopping patterns by enhancing the shopping experience both from the interaction and the perception points of view. And also this research could lead to advantages such as inventory and stores cost reductions and sustainability of the garment production from a retailer side, and instead from the customer side, an increased purchase confidence and brand trust, and also an increased realism, engagement, and number of purchases in these kind of experiences. I really thank you for your attention.
Thank you. Let's thank the speaker. Do we have any comments or questions? Steve?
Really fascinating work, and I think important. I'm trying to understand, however, the pseudo-haptics component, and certainly in buying clothing, what something feels like is going to be really important. And one silk shirt is going to feel very different from another silk shirt. What is it that you're actually providing? It looked like maybe I was seeing moving the mouse, for example, in the desktop, or maybe moving a controller and seeing the fabric respond in some way. But I guess I'm trying to understand how you actually get any perception of what it feels like.
Yes, thank you for your question. As I was saying, we are first trying to provide this kind of perception by using as an input tool the mouse with the progression of images, and then the objective will be to use as an input tool no more the mouse but the controller. Of course, the literature about pseudo-haptic effects such as visual and also auditory feedback for fabrics is still really limited, and also as far as I know, the pseudo-haptic effects were conveyed with the spatial augmented reality but not with virtual reality. So this is actually the challenge.
Thank you.
Thanks. Do you have another question? Yeah. I'll get back to you.
Right. Thank you for the presentation. I'm just curious because there are multiple properties of a fabric that people would like to examine when before they purchase something. So for example, thickness, porosity, softness, or maybe smoothness of the surfaces. Have you considered looking at each of these properties independently in terms of the design of your experiments?
Yes, thank you for your question. Of course, yes. First of all, I started from the property of compliance. So starting from this optic object property, I'm studying how to convey the softness and hardness property of the material, but then I plan to create such as a visual library of these properties. So considering also elasticity or porosity, roughness, other kind of properties that I also extrapolate from a survey about pseudo-optic effects in virtual environments. So this was the first study because I started this path only from a month, but my aim is to create this kind of effects based on each property that could be useful to convey in a shopping context.
Mm-hmm. Then I have a follow-up question. So this is more out of my curiosity. So I wonder if when you combine all of these properties, are they like a linearly combination, or is there some more complex functions that you need to consider when you combine them together in your simulation?
Yes, it will be a complex simulation because I was planning first to create independent simulations, and at the end also for my research career to create a combination of these properties to see how they work together in the same simulation. But I have to do further research to develop these, but it is one of the further study. Thank you for the for your suggestion.
Thank you.
Thanks. So, should we move to the next speaker? And thanks again, Marina.
Thank you.
So, our next speaker is on site again, and let's welcome Jesper Garsdal with his presentation, Immersive Animation Authoring in Industrial VR Applications. Stage is yours.
Thank you. So yeah, my name is Jesper Garsdal. I'm an second-year industrial PhD student with the company Synergy XR and Aalborg University in Denmark. And for my PhD project, I'm working on immersive animation tools for industrial use cases and industrial end users. So first, a bit about me. It's been a while since I finished my master's degree and have since then worked several years as a consultant, creating various AR and VR solutions for large manufacturing companies in Denmark. And it has become increasingly popular for these companies to use VR technologies for their onboarding and training of new employees. But it's quite expensive for these companies to continuously purchase large customized training solutions from third parties. So they are looking for solutions that will enable them to create these solutions themselves and manage their training procedures themselves. And the company Synergy XR provides such a solution where they can, the organizations can create virtual spaces and upload their own content. But much of this content is still being provided by third parties, as the companies, they lack the technical expertise to create these assets themselves. And one piece of important content is animations, as they can be used to explain and visualize complex topics and mechanisms. And the industrial experts creating these training procedures will often have no experience creating animations. So during this PhD project, I will explore methods and tools that will enable these industrial subject matter experts to create animations while in VR. So for my first study, I wanted to look into how a general purpose animation tool might be designed for users with no technical skills. And I decided to base it on performance animation and motion paths due to it being a very direct and visual way of creating animations. And it's easy to display a motion path directly in the 3D space with the user, creating a very direct connection between the user and the animation. So the keyframes are generated at fixed distances, and one thing I'm doing a bit differently is that I'm not using the time between keyframes to control the animation speed. Instead, I create a constant animation speed throughout the animation. And this is something I tested during pilot studies, where I first tried using the time between the keyframes. But what we found was that users less experienced with VR would spend a lot of time making small corrections, and this would be reflected in the final animation. And they would have to correct this slow animation speed at points afterwards, which created a poor user experience. So we decided to go this way instead. The keyframes can also be edited by selecting a keyframe in the 3D space, which makes the object jump to that keyframe, and manipulating the object will then modify the underlying keyframe. So I evaluated this during a mixed methods expert user study with 7 participants, including 3 industrial experts from a Danish manufacturing company. And during the study, the participants would be asked to complete 3 animation tasks designed to test different types of motion. And for each task, the participant would enter a new virtual space prepared in advance with 2 object setups. One that was already animating, showing the participant, the animation they would have to recreate. And the second setup was for them to animate. After completing the tasks, the participants would be asked to fill out post-task questionnaires, a system usability scale questionnaire, and a questionnaire for user interface satisfaction. And lastly, qualitative expert interview was conducted, and audio recorded and transcribed for later thematic analysis. The results of the post-task questionnaire showed above average scores, and the participants in general found the tool enjoyable to use and easy to use and intuitive. One participant and a freelance animator that was added as a sort of a control group to the study did note on not being able to adjust the animation time between keyframes, but none of the industrial participants commented on this. For my second and current study, I'm looking into a more specialized type of animation often found in industrial use cases. Exploded views are very useful in industrial applications due to being able to show the parts that make up an assembly or piece of equipment, and also for VR training, being able to show how a piece of equipment might be assembled or disassembled. So drawing inspiration from the body of work from within assembly sequence planning, I've created a prototype able to automatically create exploded view animations within an animation boundary that can be modified by the user in order to adjust how parts are spread within a specific direction. The calculations are based on oriented bounding boxes in order to simplify it and make it able to run it at runtime. So for intersection tests, I'm using the separating axis theorem. And the calculations I'm doing are 3 parameters. It's direction and order and distance. So for the direction, I'm instead of just the oriented bounding boxes provide us with 6 possible directions that are the local axes of the bounding boxes. Instead of just testing all 6 directions in a random order, I'm prioritizing. First, looking if the object is much larger in one axis than in the other 2, I prioritize that. Secondly, I look at neighboring parts, so I try to find the closest neighboring part, and using the separating axis theorem, I get the axis of separation. Or if there's a small intersection between the neighbors, then I get the axis of least penetration, and I test those. If these first 2 priorities fail, then I look at the direction vector from the centroid of the assembly and to the center of the bounds and get the closest matching local axes of the part. For the order, I prioritize the parts that are furthest from the assembly centroid first, test those. And then if a part can be moved in any other directions I test it again during the next iteration. And for each iteration, the order increases. The distance, the max distance, is controlled by the animation boundary. So I find a point on the boundary by doing a ray intersection between the part in the disassembly direction and to the bounds. And the actual distance that it receives is a calculation based on the parts that a part will intersect with when it's moved and their order. In this way, the parts can be separated out through the space that is available in that direction. So for future work, I would like to extend on this motion path tool from my first study. And I'm currently supervising a group of undergrad students working on extending it to multiple objects, so creating animations with multiple objects using motion paths. I would also like to explore a node graph approach, treating the motion path as a sort of graph and the keyframes as nodes where other nodes might be applied to, in order to make it a more modular system and to solve some of the limitations I know I have right now. Using motion paths, it's difficult to have an animation without any translation because there will be no motion and it won't be visible. So hopefully this approach will be able to solve that limitation. For my current study, the exploded view animations, I'm currently working on the VR interaction for the prototype, and I would also like to look into other types of user input I might take advantage of to modify the outcome. So for example, being able to modify the partitions that parts are separated into, the layers, or also be able to modify the direction of a part. The distance calculation, I would also like to make it aware of obstacles in the virtual space to avoid animating parts through walls and floors into other objects. Then of course I'll need to experiment on more models provided by some of our industrial partners. Ultimately, of course, I would like to do an evaluation of this, preferably a comparative user study. And then I'm considering a poster submission for this, maybe for IEEE VR or another conference. And those were the words from me, so thank you.
Thanks a lot. Do we have any questions to the speaker?
There's one.
Oh, sorry. Checking if the tutor online has one.
Thank you very much. Very nice talk. This is incredibly important work. I was just curious, you have this automatic determination of the direction of the exploded view. Is it going to be that helpful if it's not right, you know, a certain percentage of the time, to just say explicit, just have the user explicitly state the part or the group of parts in the direction that they're going to go in? Is it why didn't you go with the explicit definition of the animation?
Well, what I'm hoping to do is to basically not have the user have to do any kind of input most of the time. If I can avoid them having to do any modifications or anything, it will of course be the easiest for them. But I am also aware that there'll definitely be some cases that I can't support using the method and this simplified method of using oriented bounding boxes. So that's why I'm considering adding a user input where they can, after they have gotten this automatically created animation, then being able to modify it and choose a different direction.
I do like your graph. So it gives them an abstract view of what is happening, and then they can move particular objects from one node to another node. And I think that is a really good direction. Have you thought about explosions that are not orthogonal?
You mean based on the global axes or just based on any direction?
Well, you have these you can have objects that are not rectangular or.
Oh yeah, I have in the lower video here, which is not playing, probably because the presentation is done. I have some parts that are moving diagonally. But yeah, I'm allowing 6 different directions based on the local axis of the bounding box. So if the bounding box is rotated, then that will be one of the possible directions. And I'm using that for this bottom assembly.
Okay, thank you.
Yep, one more question.
So yeah, let's coming to you.
Okay, I think there's been a lot of work people have done on trying to automate this, and it's a really hard problem. Have you thought a bit about rotation?
I have thought about being able to create like multi-step animations of the parts, and I have seen papers where they have experimented with this. It's a very complex topic. It is something that I have considered doing in a secondary study, extending upon this work, either doing rotations during the animation or just doing two-step animations of parts. I haven't looked further into it than I've found a couple of papers that have done it, but yeah, it's something I have considered.
Even things as simple as a bolt and a nut, instead of just pulling them straight out, actually unscrewing them.
Yeah, that would be cool. It's also very complex because since I'm just using the bounding box, I don't have any information of whether the object is a bolt or a screw. But it's something maybe a user could provide as user input. It's definitely an option.
Okay, thank you.
Yes, thanks. I want to add the two previous comments. Definitely, I am a mechanical engineer, so I do teach those CAD software, and actually the CAD system knows the threads, so they know most of the joints, the cylindrical elements. And even with that, they're still not able to do a correct explosions. So I'm talking of the best CAD system on the market. So this is a really interesting topic. It will save a lot of work to the final user. So in any case, the geometrical approach using bounding box maybe is not sufficient, in my opinion, to get a reasonable explosion. So if this explosion is technically must be technically sound, probably I suggest I recommend to use the full geometry, and eventually even consider what is available on a CAD. So actually threads, cylindrical faces, planar faces, and even consider AI. By, for example, maybe you consider this to make a post, an engineer or somebody evaluating them by manually evaluating the results as a feedback of the animation. So did you have this in mind, or it's too complex to introduce AI?
I agree there will be many cases where the exploded view won't be technically sound. And just considering a nut and a bolt, of course, the bounding boxes are going to be intersecting from the beginning. So it's, there will be a lot of cases where it won't be technically sound. But we've also sort of scoped it down to that it's okay, it's not technically sound, because this is for VR training purposes and for onboarding and demonstration purposes. So what we have received of feedback from our industrial partners and what we're thinking ourselves is that it's okay that it's not completely perfect, as long as it tells the right story and shows the right concepts and topics.
Okay, thanks.
Thanks, Michele. Do we have any other? Okay, then thanks again. And yep. I'll call the last speaker for this session. Okay, then let's welcome our last speaker, Manjeet Singh, with the submission titled Augmented Reality Enhance Analytics to Measure and Mitigate Student Engagement in Young Children. The stage is yours.
Thanks for the introduction. A very good afternoon to everyone. My name is Manjeet, and I'm a PhD candidate with Deakin University in Australia. I'm from Singapore, and it's great to be back home today after 4 years. It's a great pleasure to present my research on augmented reality enhanced analytics to measure and mitigate disengagement in teaching young children. First of all, I'd like to welcome, on behalf of all the Singaporeans here, to all of you to our lovely country, Singapore. Student engagement or disengagement is a global phenomenon, and it's seen by teachers, the school leadership, and educational authorities as one of the biggest challenges school teachers face daily in classroom. Some say it is the single biggest problem. It is essential that reducing student disengagement is critical for the overall learning experience and outcomes. From an Australian study in 2015, current strategies used in measuring disengagement in student comprises student self-reporting, experience sampling, teacher rating of students, interviews, and observations. In 2020, I was involved in the creation of an AR-enabled children's storybook in partnership with Deakin University and a primary school near Melbourne. The Hattie and Harry Forest Adventure was written by school staff and was designed for young children to learn about saving the forest, loving nature, promoting concept of sustainability using augmented reality. This was targeted at prep students and those in year 1 and year 2. So we are talking about ages between 5 to 7. Another exciting AR project that I was involved in is the drumming AR app to enable user hitting the drums, which are represented by the mushrooms, with virtual drumsticks. Using the drumming actions left and right, I started to use AR to analyze gross motor skills in young children, such as crossing the midline, because it helps with cognitive development, especially with young kids. In both the projects, I was interested in capturing and measuring analytics on user interactions, movement, task details, user feedback, using an analytics dashboard, which is now the basis of my research. I'm happy to share that a journal paper still under review and a poster paper has been the outcome of the submitted on these 2 projects. To address my research thesis, I approach by defining 2 research goals rather than research questions. The first goal, VARA, is to compare analytics collected using AR applications with respect to providing detailed and relevant measures of student disengagement when compared to existing strategies, as I mentioned earlier, and then to develop and validate these metrics based on AR sensors and application data as measures of student disengagement. My second goal, PARA, is to assess the value of effectively presenting disengagement metrics through a live AR dashboard as a tool to provide teachers with a way to assess and mitigate disengagement. Compare AR information presentation strategies to determine an effective mechanism for providing school teachers with real-time or near real-time, as the reality sets in, individualized feedback on individual students' engagement levels. I've done a systematic review and I'm sharing one aspect or one portion of it, which in the interest of time, from the review of literature, which provided valuable finding, especially studies utilizing various instruments of measure. The metrics which were measured by the devices are listed. Task time, user sessions, user-specific data is widely used to give usage analytics of the AR tools, or the AR app, as what we call it. We do note some unique measures which have been used, such as object manipulations, GPS positions, brainwave data, temperature, humidity, and also distance-related measures, such as user distance from an AR marker or an AR asset. We will next discuss how these metrics form the basis of my 5 dimensions of AR enhanced analytics for use in education settings. I hope to further explore their use in relation to factors which relate to a student's learning outcome, as well as where students' disengagement is one of them. For the area, as I short-formed it, measure of disengagement, I've started using the various devices and sensors to capture novel metrics, including current work in spatial analytics, which I've been working with an Australian-based AR company as part of my PhD industry research collaboration. I hope to gain more insights and knowledge from prior studies on various multimodal analytics techniques, which can adapt to the measure of disengagement in my research among young children. Next, I will share my research methodology based on my two goals. Firstly, the goal to develop and measure AR-enhanced analytics. My method uses a stringent review of current literature to inform the various AR-based analytics already used in reviewed studies and also the instruments of measures of these AR-based analytics. I've developed and used AR-based metrics for the measure of disengagement in the 5 key areas using devices and sensors. So some of this could be facial semantics, body movement, task-specific, biometric data, and activity data. Mobile devices-based AR prototypes were developed using an area engine architecture to analyze and process for insights as needed for presentation of the data to perhaps the teachers. This proposed architecture is being presented as a poster paper in this conference. I would like to share more over the next few days, and do visit the poster. The area engine includes functionality to measure AR-based analytics, integration of instruments of measure of AR mobile devices, use of storage, processing of AR-based analytics. And finally, to output the analysts to present to a presentation layer like a dashboard. And specifically for teachers. I mean, as we know, teachers in the classroom are time for focus on students' performance, learning outcomes. So how would we design a dashboard? So what we have here on the screen, you can see, we have prototyped a sheep shearing app. Coming from Australia is an obvious choice to learn how to shear the sheep. So we have an AR app which challenges young kids to engage in learning about wool, learning about agriculture, the sheep, and stuff like our animals in Australia. And while they are engaging with the AR assets, data analytics is captured and then presented. Over on the far right, we'll see a prototype dashboard that shows the movement around the asset as the child is moving, the sessions, details on the sessions, details on the device direction, and also has a feature to replay the whole motion. This is the data capture stage, and I hope to make more sense of this data and apply it to the disengagement studies that I will do in my future. To test the area metrics and area engine, user evaluation sessions has been planned, but unfortunately on hold due to research restriction in public schools in Victoria, Australia. This has since been most challenging phase of the research for me. I'm sharing my research, I'm also sharing my sad stories. With ethics approved and subsequent modification done from the school setting, so I can't go to the schools, I can't test with the users, not allowed. I've applied for ethics modification because I'm dealing with young kids, low risk. I'm now starting to evaluate sessions with young children in public events. So this could be community days, fun fairs, has kids come out with their families in areas. That's where I've started doing my evaluation. I do look forward to the pending approval from the Department of Education on the lifting of the COVID restriction, and so that I can continue the school and classroom setting evaluation with the students and subsequently interviews also with the teachers. Moving on, this will include recruiting participants, teachers, students in the partner school. About 20-25 students will be involved in the parent consented consideration of the school policy and allowing the human ethics approval by the Deakin University and also the Department of Education. In a single session, I will collect data and measure of disengagement via the area engine to collect AR-based analytics from the devices and sensors, and via current methods used by teachers, which are namely observational, post-interview, teachers' feedback to arrive at an alternate measure of disengagement. From the two sources of data collection for each session, I will analyze and validate the measure, comparing with current methods and determine through evidence of the measure of the disengagement is consistent with the disengagement matrix gathered from non-AR based sources, such as the teachers' expert feedback of students who are disengaged, who are not paying attention, who are running around. Bearing in mind, these are young kids. These are 5 to 7 year old. They have just moved from kinder to a primary school setting. And these are the challenges that teachers face, and I'm trying to address that, how I could help them. This experiment design is currently being done, and this is where I hope to leverage this doctoral consortium session and also the mentoring to proceed ahead with the valuable feedback and prior experiences from fellow researchers, especially in the school settings, primary school settings. The second goal, to develop teachers' dashboard for the presentation of AR enhanced analytics for disengagement, uses a user-centered design process. The method starts by identifying teachers' needs in a dashboard to give real-time insights. Firstly is to specify the context of usage of the dashboard and then gather the requirements. That is one of the prototypes where the teachers actually see avatars or representation of their students and looking at values and matrices to gauge their engagement of the lessons that had been completed or being in session. Design of the dashboards are produced and evaluated with the teachers, and it's still satisfactory system to be developed as yet. This is an iterative process to continuously use agile methods of software design and evaluation. My research plan covers the next phase of research. I'm in my second year of my PhD, and this is the plan for the next year. It includes the phases for WARA and PARA, and also the evaluation sessions that we have. I'm happy to share the completed milestones to date, which I'll quickly go through. This is all have been mentioned earlier. Thanks. In a nutshell, while going through the research, I wanted to share my research with the education community, especially with schools, engaging teachers to participate in the research. We have set up a website, the Forest Classroom AR website. Do visit it. We are inviting teachers, especially from Australia, to get involved in the project and to see how AR can leverage in terms of lessons in schools. I'm confident that the research will contribute to the knowledge in AR-based application and tools utilizing AR-based analytics that are collected real-time or near real-time, the comparative study of relevant measures of disengagement when compared to existing strategies in classroom learning, to develop and validate AR tools to support and mitigate disengagement using the area engine, providing opportunities for teachers to be more effective in identifying areas of student disengagement, and to contribute ongoing research for better understanding in developing teachers' AR dashboards, addressing the problem with young children such as disengagement, restlessness, and boredom in the education settings. That is the end of my presentation, and I thank you for your attention.
Let's thank the speaker. Do we have any questions? So, Mr. Jens.
Hello, I'm Jens Grubert from Coburg University in Germany. So thanks so much for your talk. So my first question is resolving around this disengagement and engagement here. So you said you're basically doing research to ideally measure and hopefully at some point also improve the engagement, but this also assumes that there's a more or less direct correlation between, let's say, the engagement and the learning outcomes. And now my first question would be, like, is this always the case? Yes or no? So would you also like directly focus on learning outcomes, like actually that children learn something in a better way than without your technology? So this would be my first question. Yes, thank you so much.
There is a key component on learning outcomes. Based on my literature survey, I found that engagement, disengagement are the effective factors of learning outcomes in school, and especially young kids. I hope to further build on the learning outcomes studies that I've known and to build the measures. At this moment, I've just got analytics and metrics. I don't know how linking it to the disengagement, that is my phase that I'm looking at. Disengagement is huge. When I first chose the thesis, I was dissuaded. Disengagement, engagement is a huge topic. So many definitions. I hope to finalize or focus on an engagement with a definition, prior to moving on into the next phase of my research.
Okay, thanks.
Any question? You have a...
I have a bunch of questions, but I don't want to steal the time of others here. So.
And Jens is my mentor, so...
Yeah. I better have some questions, I guess, right? But...
Hi, thank you, Manjit. I'm just curious because I have kids, 8 years old, so I'm interested in this, but I find that usually when there's a new technology or new things for them, they are very engaged because of the novelty factor.
Yes.
But then afterwards, they sort of get bored or they get interested in something else. Yeah. So for this type of studies, how do you disentangle this novelty factor from your measurement of engagement or disengagement of the kids?
Yeah. Novelty factors is with kids. We have been kids, we know our attention span moves on pretty fast. This is where my preliminary discussion with teachers, we are looking at collaborating with their lesson plans. So it's not only a total AR lesson that we're looking at. The AR will complement their traditional style of learning. So while the kids get bored halfway doing work, they will engage with the AR, get engaged, and then the teacher will get them back onto the work. This is the strategy, and we are trying to test this method with the teachers through our evaluations as well. So for example, if we are talking about wool, studying sheep, there will be a paper learning about Australian animals, and the kids will, in part of their lesson, will engage in AR and then come back to it. Yes, I agree with you, it'll be a one-off, they won't come back again. But the game, there's a bit of a game element to it. So they actually shear the sheep, they go around the sheep trying to get rid of all the wool within the time factor. So trying our best to get a novelty effect done.
So I guess the design of the application, you have to keep designing it for different lesson plans.
Exactly.
So,
Yeah.
right. Yeah, thank you.
Thanks.
Thanks. Do we have any other questions? If not, then we are at the end of the doctoral consortium presentations. Again, we have a coffee break, 15 minutes, and then, or however you kind of negotiate with your mentors. There is this reserved slot for 1 hour to do the one-to-one mentoring. Again, there is on-site. On-site is easy. You just look for a space. This space is available, but also outside there are quiet empty corners. For all the other combinations of on-site, online, and online, we have set up the GatherTown system. We'll post the link again in the Zoom session. And if you have any problems finding your mentor or anything, please send us an email. We would like to thank everybody who attended, specifically our mentors who take the time to kind of read all the submissions and take time to mentor the students. And yeah, with this, I guess we're closing the DC officially, at least from our side, and we wish you a really enjoyable and good conference. Thanks.